Hi, folks. Welcome back after a few hour break between day 2 and day 3. We're gonna start with a great presentation from Giri, but first, it's at the beginning of the conference, day 3. So I need to share some organizational details for the conference. So first things first, the most important. Because we are available on a few different streaming platforms, you can interact with us through comments. And I'd like to remind you and ask you to remember to respect each other and follow the code of conduct for the conference. If it comes to all the information about what talk is starting in a few minutes, or that we have a longer break, or how you can provide some feedback about given presentation, there's a great group of people helping out organizing the event. They will share in the comments, in the live chat information whenever something new starts. They will also share with you link to code of conduct. They will also share with you two super important links for us, which are links to surveys. One is about the audit of AsyncAPI brand. We're super interested what you think about current brand. And also important, pretty simple questionnaire with 4 questions about AsyncAPI and especially the next year event. So please, whenever you're going to see people posting links to surveys, please take time. It's like less than a minute to fill them out and give us information that we need. Now, if it comes to Twitter users, short break. If it comes to Twitter users, we have a special hashtag that we follow. So hashtag AsyncAPI Conf. Please use it to spread the news about the event. If it comes to the and speaking of so if it comes to organization of the event and then sponsorship, throughout the entire conference, you're gonna see the list of platinum sponsors. But just keep in mind, on the website, you're gonna see also that we had gold sponsors, which was Red Hat and SmartBear. In addition to these 5 amazing sponsors, which is Postman, Abli, WSO2, IBM, and Solace. So thanks a lot to all the financial sponsors, but also a special thank you to Restream.io that gave us for an open source project, a special license that we have like full access to all the features, and that's why we can run the entire conference through Restream Studio and broadcast to all our social accounts. So you noticed at the beginning, the registration was done through Zoom. We thought we're gonna end up there and then streaming to other platforms, but technically it was much easier to do it and much better to do it with Restream. Sorry for all the breaks, but you can notice that it's third day of the conference and I'm speaking a lot and it costs. Then if it comes to the Zoom and all the confusion that we caused by just moving the conference to other location, we, for people that took time and registered with Zoom, and next week, Wednesday, once we calculate all the budget spendings we had for the conference, we're going to see how much money left. We will do a raffle, like we're going to draw from the list of all the emails, a number of email addresses, and then send information that we would like to send you a swag pack. Please look into your mailboxes after next Wednesday. Important information about streaming to LinkedIn. LinkedIn streaming is still in beta. So even though the whole conference is like about 8 hours and it's available on Twitch, on Twitter, and YouTube, on LinkedIn, it's only 4 hours. So the limit for a stream is 4 hours. So please don't be surprised that in about 3 hours, the streaming on LinkedIn will finish and will not renew. So simply just please jump into other platforms. And last but not least, very important information. On the day 1, on day 2, and also day 3, we had one presentation that could not be delivered. Luckily, yeah, we have amazing community. The response was pretty fast. So today, the last presentation that was supposed to be delivered by John at the end of the conference, will this presentation will not take place. But in exchange, we're gonna have Greg from Solace presenting the event discovery solution that he actually provided as a submission for our AsyncAPI hackathon. So if you're not familiar, throughout the entire October, we had a hackathon, and one of the runner-ups for the hackathon was Greg. And yeah, we're gonna have a chance to see his presentation about the event discovery. So pretty interesting stuff. And huge thank you to Greg for delivering presentation in such a short time. Because, and that's the last information, remember, all the presentations are pre-recorded. But it doesn't mean speakers are not with us. So Greg had to record the presentation, you can imagine, pretty fast. But Greg and others will be there to answer all your questions, all your concerns, and yeah, help to get rid of any confusions. And that's why, for example, now when we will jump into a presentation called AsyncAPI plus Spring Cloud Stream equals event-driven microservices made easy, the talk will be delivered by Giri from Solace. And even though it's pre-recorded and I'm going to play recording, Giri is here with us. So I'm going to invite him now to the stream. Hey, Giri.
Hey, Lucas.
So yeah, Giri will be here throughout the entire presentation, and also will join live to answer all your questions. So feel free to ask your questions during the presentation or at the end of the presentation. Giri will come in and will address them. And like Giri, would you like to add something before we start the presentation?
Great. Hey, guys. Looking forward to have your feedback on my thoughts, what I shared on the Async API and Spring Cloud Stream. So I'll look forward to connecting with you at the end of the session. Thanks, Lucas.
Perfect. And again, sorry. I will definitely have to take off tomorrow. So yeah, thank you for joining. Let's go back to the backstage and enjoy this presentation, and remember about asking questions.
Advent of open standards and modern development frameworks, building complex systems is becoming easier by the day. In this session, we'll be exploring how AsyncAPI and Spring Cloud Stream makes development of event-driven microservices easy and friendly for developers. Hi, my name is Giri Venkatesan. I'm a developer advocate at Solace and happy to be connecting with you at AsyncAPI Conference on this session. So we'll take a real-world scenario as a use case and explore how the requirements are met by the use of AsyncAPI and Spring Cloud Stream throughout this session. Let's consider Smart City, a contemporary concept that we are all familiar with. Smart City is a framework that utilizes information and communication technologies to develop, deploy, and promote sustainable practices to meet the urbanization challenges. Right? It requires smart solutions to manage the needs around energy, mobility and transportation, health and education, and various other aspects that formulate smart city. Right? As we speak, we have numerous functioning smart cities that are successful around the world, New York City, Singapore, Amsterdam, Helsinki, Zurich, and many others too. Key enabler for the success of smart city is open data. Let's talk about open data a little bit. Historically, governments, enterprises, and individuals have held their data close, sharing as little as possible with others. True impact can be realized only when all the participants in an ecosystem share data and information, leading to the ability to make informed decisions jointly in real time. And smart city definitely needs open data. Open data is, in a sense, redefining this entire digital transformation across the ecosystem. For our session, we'll be examining the needs, probably I would say a specific subset of a mythical smart town where APIs are a way of life, to demonstrate AsyncAPI and Spring Cloud Stream, what impact it has on the EDA. Right? Though the smarter requirements are exhaustive, for this session we'll be looking at a subset involving temperature monitoring and management. This involves receiving and processing temperature readings from various sensors deployed across the town, parks, public facilities, vehicles, and so on. We'll also be building services to simulate the temperature sensor readings and generate operational and aggregate alerts as events. With that said, let's analyze the possible interaction between the services and the application in this context. The controller interaction with energy management system is to affect temperature changes. Obviously, it requires a synchronous request response interaction based on REST APIs. It's great. The rest of the interactions can be event-based, meaning asynchronous, and can use pub sub operations mediated through the intermediary, what we see as an event broker, right? So in this case, the events are published around temperature reading and various alerts. Services and applications create their subscriptions and consume these events when the broker delivers to them. Event gateway, essentially an event broker, mediates the interaction between the publishers and subscribers and offers decoupling and subscription-based event routing. Okay? So this is what makes up an event-driven design for a particular problem around temperature monitoring and management. Okay? Here's a fun question for you. APIs are only asynchronous in EDA. Is it a fact or is it a myth? Right. So you have 10 seconds. So please give it a thinking, and let's see if you get it right. All right. It is a myth. Simple reason is digital transformation journey is nothing but an adoption of event-driven architecture on top of existing architectures. This could include harmonious interaction between microservices and applications in an ecosystem. So it can be asynchronous as well. It can be both synchronous and asynchronous. Let's talk about AsyncAPIs. AsyncAPI is an open source initiative that seeks to improve the current state of event-driven architectures. That's great. The goal is to make working with EDAs as easy as it is to work with REST APIs. That goes from documentation to code generation and discovery to event management. Right? So most of the processes that you apply to your REST APIs nowadays are applicable to event-driven asynchronous APIs too. So the AsyncAPI specification settled the base for a greater and better tooling ecosystem for the EDAs. So that's the foundation, or that's the purpose of AsyncAPI. Right? Let's look at broadly at the APIs and the API specifications. APIs are nothing but application programming interface, right? They make it easier to exchange information between applications, tell you what kind of information to be passed as a request and what to expect as a response, and so on. API consumers at any point in time don't need to know the how part of the implementation. It's completely hidden from them. It is true for both synchronous and asynchronous APIs. The operation-wise, in a synchronous context, you will be invoking the APIs, whereas in a asynchronous context, you will be either publishing or subscribing events. So only the operational terminology changes, but they are still APIs. In essence, building APIs can be tough and time-consuming. Absence of standards and tools can make it even more difficult. Here comes the specification. We have OpenAPI specification for the synchronous APIs, aka the REST APIs, and an AsyncAPI specification for the asynchronous APIs, in this case, event APIs, right? And then if we, extending this further, API standards and specification help the developers with tools to generate documentation and code, as well as act as a repository for lookup at runtime. So instead of exchanging this API specification on a informal medium, now you have a centralized repository where they can be looked up, and they are standards-based. That means tooling ecosystem can evolve to generate codes for various frameworks and so on. Let's see how the asynchronous API draws a parallel to the synchronous APIs. Both of them deserve a portal, right? In the case of synchronous, we call it an API management portal. And then in the case of asynchronous, we should call it as an event management portal, because the interaction is completely based on events being published and subscribed, right? So both synchronous and asynchronous APIs needs a centralized portal for managing APIs, right? It starts with cataloging, versioning, and maintaining the APIs, essentially a public repository that can be queried at runtime. A specification is also required. We have OpenAPI for synchronous APIs and AsyncAPI for the asynchronous APIs. And then when it comes to tooling, Swagger is a tool for generating code from the specification for REST APIs, and AsyncAPI is also a tool that can be used to generate code for asynchronous APIs. When you look at the generated code, here's where the difference comes in. When it comes to REST API, it's a simple client-server interaction on a protocol, which is a single protocol, that is HTTP. So the Swagger generates the client stubs and server stubs from the specification. When it comes to AsyncAPI, AsyncAPI generates code for the widely used frameworks like Spring, Node.js, Python, and so on. And then it also supports various protocols, AMQP, MQTT, WebSocket, and so on. The simple reason for multi-protocol support is underlying broker that's offering this publish subscribe capability might be supporting or might be requiring support for various protocols. So it automatically gets bubbled up and supported at the code level. All right. Now, another question. The statement goes like this: I will have to redesign my REST-heavy architecture from scratch to adopt EDA. Is that a fact or a myth? Let's see. You have 10 seconds. Just take a shot at it. And it is a myth. Simple reason is, the REST-heavy interaction and the asynchronous interaction can coexist. Nothing has to be dropped. Nothing has to be adopted from the scratch. So a digital transformation journey is basically, adopting a new architecture with its legacy infrastructure still in place. So you don't need to redesign your architecture just to adopt EDA. All right. Let's get into a bit of a comparison and working together. The 2x2 table or map on the left-hand side clearly indicates what tool to use for what purpose. Synchronous, point-to-point, or one-to-one, straight away, it's REST API using OpenAPI specification. For anything asynchronous, it is AsyncAPI. All right. On the right-hand side, let's kind of explore a real-world scenario, an e-commerce application, and see how the synchronous and asynchronous nature of interaction comes into play. There are applications we are looking at, order management system, warehouse, and product catalog management and marketing operations, right? So these are already existing in the infrastructure, and they have already exposed REST APIs for applications and services to interact with these systems, right? Now let's take a look at it. Every single interaction might end up in generating an event right? For example, a new order placed on the order management system could kind of publish an event, could publish an event called received. And then when the order is processed, it could publish an event called processed, and so on, right? So these events could be either triggered in response to a request received from other services and application, or it could be a notification event, response to some change within the application systems. Among the events generated, it's quite possible to identify and expose certain high-value events that may be of interest to both internal services and applications or external applications. All right. This is nothing but event enablement, and it's a first step in the event enabling process. All right. So let's take a look at this. When you look at this picture, we have these products. It could be internal or external. Delivery service provider, he need to know about when an order is shipped or processed so that he can pick it up and then initiate the shipping. Similarly, price comparison tool could be an external product that need to operate only on the product that are promoted for sell status. So that ready to sell event is published from the product catalog, right? So you can see here the events acts as a bridge between these applications and the products, utilizing this asynchronous nature of communication, right? So here the REST APIs and the event APIs can coexist. We'll have a quick demo on AsyncAPI. For a quick demo, we will check out the standard tutorial/demo that's in the AsyncAPI website. It's about streetlight systems that's publishing the environmental lighting value to a broker. Right. The technology that we'll be using is Node.js for the code and Mosquito as a broker to provide the PubSub service. Right. It simply publishes the event, basically like a fire and forget. There's no other processing involved for simplicity's sake. And here is the AsyncAPI specification file. You can assume it's pretty much hand-coded. This section clearly indicates the AsyncAPI version, and then more on the application details. And this server construct indicates how to make connection to the broker. Mosquito broker that can be located at this URL using MQTT as a protocol and so on. And the channels is nothing but a collection of topics that this application can publish or subscribe to, right? So here is a channel name, nothing but a topic name. An event can be published to this topic with a message whose structure can be like this. So it's a message. Its payload is of object type and contains properties like ID, lumens, and sent-at, and their attributes and description and so on. And one thing to notice, the operation ID is an attribute that give a hint to the code generator what to call the function that publishes this event. All right. So once the AsyncAPI spec is ready, we can put it through standard process. I'm just going to kind of gloss over certain steps like installing AsyncAPI code generator, and then creating the AsyncAPI spec as a file, and then running the code generator. It's nothing but AG is the tool name, the YAML file, and then the template. So this template can vary depending on what output you want. In the case of Node.js, it's Node.js template. In the case of Spring, it will be Spring template and so on. And the output directory and a few specification around the server type and so on. So this will generate the full-fledged code for this Node.js framework, and it's available for us. Okay. And at that point in time, you can simply start the generated code. Of course, if you want to implement your custom business logic for event processing, you can go ahead and do that. Otherwise, a standard functionality would log the messages received on the application. Right. So you start the application and continue to publish. You should see events being exchanged, subscriber and publisher in action. Let's go and check it out. I'm going to switch context here. So I have 3 windows that's already open and ready to go. So this is a command you would be used to generate the Node.js project code base, which is already done, as I mentioned. Here is the code. I'm going to simply start the application. Okay. it subscribed to this. It made a connection to the MQTT broker, sorry, Mosquito broker, and it subscribed to this topic light measured. And in this window, I'm going to publish an event like on the topic of light measured and specifying host information and the message payload in the form of a JSON. Okay, let me just publish it. So you can see the published event is received here. And similarly, I can also create another subscriber, MQTT subscriber on the same topic. I keep the subscriber also ready and running. Now I'm going to publish one more event. You can see both the AsyncAPI generated code as well as the command line MQTT subscriber. Both of them will receive this event. Yep, there we go. All right, so that's the quick demo that I wanted to show around AsyncAPI. Spring Cloud Stream. A Spring Cloud Stream is a framework for building highly scalable event-driven microservices connected with shared messaging systems. It also provides components that abstract the communication with the many message brokers possibly out there away from the code. Right? It uses features of Spring Boot, Spring Cloud Functions, Spring Integration, and Spring Messaging, making it a part of the broader Spring stack. Right? One of the key benefits of using Spring Cloud Stream is instead of having to learn messaging APIs of different broker systems, developers just have to understand the communication model that Spring Cloud Stream supports. When it comes to the communication model, there are 3 supported models, but the support for each of them varies from binder to binder. First one is the publish subscribe, which is a traditional one. Subscribers are independent from each other and receive events in order. Right? Then consumer groups, basically a fan out and load balancing option across multiple consumers. The last one is stateful partitioning support, basically that brings about the in-order processing for consistency and performance. To sum it up, it's a framework for building highly scalable event-driven microservices that is connected to a messaging system and making use of the publish subscribe infrastructure. Right? We'll see more on that. So the other key component of Spring Cloud Stream is the Spring Cloud Functions. Right? Spring Cloud Function basically promotes the implementation of business logic as Java functions. Right? By doing so, we are decoupling the development lifecycle of business logic from the specifics of runtime broker, so that the code can run as a web endpoint, stream processor, or a task, and so on. Right? It also allows us to enable Spring Boot features such as auto configuration, dependency injection, metrics, etc. So let's look at the message exchange contract as a Java function. We have 3 functions. First one is supplier, nothing but an event source. In messaging term, it will be a producer or a publisher of events. The next one is a consumer. That will be an event sync. Could be a subscriber or a consumer of events. Right? And third one is somewhat unique. It's a function, nothing but a processor. It simply consumes an event from the underlying broker, processes it, and can produce an event, basically publish back to the broker. Right? So the Spring Cloud Function forms this essential methodology for implementing your messaging requirements. Okay. Let's look at the key components of Spring Cloud Stream. A binder. A binder is really the one that makes a difference and makes the framework useful. They provide an abstraction layer between your code and the messaging system through which the events are flowing. Right? And there are many binders. Few of them popular ones are binders for RabbitMQ, Apache Kafka, Apache Kinesis, Google PubSub, Solace PubSub Plus, Azure Event Hubs, and so on. Right. And next one is a bindings. Is a collection of interfaces that identifies the input and output channels declaratively. It acts as a bridge between external messaging system, a hosting, a queue, or a topic, etc., and an application provided producers and consumers. A channel simply represents the communication pipe between the middleware and the application. Essentially, it's an addressable component made available by the server where events are organized. Okay? And schema is used for serialization and deserialization, and it defines the object structure of the messages being exchanged as a request or a response. These are typically objects, but also supports primitives and arrays. Last, message. The data structure used to communicate with the bindings between your code and your message broker. It's basically the mechanism by which information is exchanged via a channel between the server and the application. It must contain a payload. Optionally, can also contain headers. Right? It contains data as defined by the application, which must be serialized into a format that's understandable by either the application and or the broker. JSON, XML, Avro, binary, these are the formats. Right. We'll have a small Spring Cloud Stream demo. For the Spring Cloud Stream demo, we'll be using the Getting Started tutorial from the VMware Spring Cloud Stream web pages. What we're going to do is we're going to download a Docker image containing RabbitMQ and Kafka applications, and then run that Docker. And when the Docker comes up, obviously we have the message broker RabbitMQ ready for use. And we'll create a Spring starter project with the dependencies on the Spring Cloud Stream and RabbitMQ binder. And with that, we'll create a simple Spring Boot application and start adding message exchange contract, nothing but the Java functions that can, that's basically the consumer bean with a name toUpper. So at runtime, the Spring Cloud Stream will interpret this as a subscriber that subscribes to a topic by name toUpper, and then it follows a certain convention that will be that will result in toUpper-in-0 as the topic name. So A, it will create a topic, and B, it will create a subscriber to the topic. Right? Whenever an event is published to the topic, the underlying message broker will automatically deliver to that subscriber, which in turn will be consumed by this function. When the function receives this message or a string, it will simply print out to uppercase. So technically, if something is published on this topic, we should see an uppercase converted string getting printed on the console when the Spring Cloud Stream project is up and running. Right? It's a very simple one, but it demonstrates this aspect of Spring Cloud Stream function, Spring Cloud Stream, Spring Cloud function, and then the implementation of message contract, and in turn going through the binder to create necessary message broker specific artifacts like topics, queues, and so on. And at runtime, when message appears, it's getting routed to this function seamlessly. In this entire exercise, we'll be focusing on building only or implementing only the business logic. Okay, so let's get started with downloading the Docker YAML file. It's already there. I am going to download this. Got it. And I'm going to run the Docker. We'll bring up the Docker. So you can see when the Docker starts, it's starting the RabbitMQ, Kafka, Zookeeper, and so on. All right. So it's ready. Now let's go and check the RabbitMQ console. It's available on this particular port. It's ready. Now we will have to go to this Exchanges tab to see if there are any topics, right? Yeah, these are all topics that's existing. These are system topics. There is no user-created topic at this stage, all right? So this is good. Now RabbitMQ is ready. Let's go ahead and create a Spring Cloud Stream project. Let me just make it bigger so that you can see things. So what we're going to do here is we're going to create a new Spring starter project and name it as SCS Getting Started. That's all right. And we will choose the dependencies. Obviously, we want Spring Cloud Stream, and also we want the binder for RabbitMQ. Okay, chosen these dependencies, and we just create a project. It's going to do all the work of creating projects, setting up the configuration. Let's just quickly review the POM file, which should indicate that we got our Spring Cloud Stream dependency made available in the class path, and also the binder for RabbitMQ available. All right. Let's open the application main file. So we have this function. Now this is the one that's going to be invoked. And at this point, we need to implement the Spring Cloud function to create consumer. Right. Let's go back and check the documentation or the tutorial. You can see here, we have done this part. We just need to implement a consumer. All right. So let's copy paste this. And paste this. Here you can see these are unresolved. Let's resolve them. It is annotation, and the consumer is nothing but a Java util function. So that's all we have to do. Let's save it, and let's run it as a Spring Boot app. Okay. When it's running, I'm going to maximize this console so that we can see clearly. Okay. Let's go ahead and publish an event to this topic. As a convenience, the RabbitMQ portal provides an interface for us to publish an event ad hoc basis. So let's go into this topic, and you can see here test publish. So I'm going to put a all lowercase hello world. Let me publish it. So you can see that message is successfully published. So what it means is this message got published to this topic, and then in turn the messaging broker sees that there is a subscriber with a subscription for this topic, and it delivers to that subscriber. In our case, that subscriber is nothing but the Spring Cloud function, and it should have received a message. Let's see here. There we go. So the message got routed to our Spring application based on the subscription it created. Right. So again, going back here, all we did is we implemented the business logic by implementing this bean function called consumer, and then we followed a nomenclature that's suitable for our application. We just said to upper. If you had called it as a process temperature or something, it would have created a topic with a different name, and everything underneath what happens under the message broker is hidden from us. As a developer, we would be still looking at as if we are doing a pure Spring application using all the aspects or the features of Spring, like Spring Cloud Functions, Spring Cloud Stream, Spring Integration, Spring Messages, and so on. Right? But behind the scene, the Spring Cloud Stream takes care of working with the underlying message broker via the binders that's made available under class path. EDA can help prevent cascading failures in a microservices architecture. Is it a myth or fact? Let's wait and see. All right. It is a fact for sure. The reason is in EDA, all the interactions are mediated through an intermediate messaging broker. So that creates a decoupling. So a failure never can affect another service and so on. In real world, EDA is pretty much useful and has found a good footing on various industries ranging from capital markets, retail banking, manufacturing, and so on, wherever there is a need for real-time messaging, right? The takeaway when you work with EDA and open standards, here is a small subset. Open standards benefits the customers or businesses from by preventing lock-in with the vendor, and this whole community-driven model has its own advantages. The best of the minds come together to create the standards and build the ecosystem. Increasing adoption in the industry is an indication that it is something to reckon with, and the resource pool, knowledge base, and all those things continuously expands. And growing interest in the tech community widens the reach and expands the resource availability. And last but not least, this whole notion of being open and community-driven fosters innovation. Let's revisit the smart town that we kind of checked out in the early part of the session. In this picture, we can clearly see there's a REST-based interaction and event-based interaction. Both are coexisting to bring about a solution for temperature monitoring and management. Right? Let's dive in a little bit deeper into each of these microservices. The first one is a data simulator. Basically, in a demo setup, we can have a sensor publishing data. So we have a program that's going to publish temperature reading periodically. So it's a microservice that uses the Spring Cloud Stream supplier contract, message exchange contract to publish temperature reading. And one thing to be noted here is all these microservices are implemented using Solace Cloud PubSub Plus broker as the messaging broker. So many of the terminologies and the conventions that you see are specific to are very specific to Solace and pretty much common across the messaging brokers as well. So what you see here is a topic name on which the temperature reading will be published. The topic name itself carries contextual information like the city, latitude, longitude, and the temperature. This comes in handy when you want to create a subscriber based on wildcards and so on. Right? And the next one is a data collector. It's a microservice that uses Spring Cloud Stream's processor message exchange contract to subscribe to temperature events and publish operational alert events. And you can see the topic on which it's being published. This is also a microservice that is built using Spring Cloud Stream. And the third one is IoT data collector, data aggregator. This is a microservice that uses a Spring Cloud Stream processor exchange pattern, where it subscribes to these operational alert events and publish an aggregate alert. In terms of processing, it accumulates the operational alerts generated for a period of time, say 30 seconds or a minute, and then aggregates the temperature value and publish a single event. Right? These are all operating on Solace Cloud PubSub Plus broker. Smart Town demo will be running pre-built microservices that uses Solace PubSub Plus broker on cloud as the messaging provider. Before we run these services, we'll take a quick peek at the PubSub Plus broker and its event portal so that we get an idea. Solace PubSub Plus broker offers an event portal that allows developers and architects to collaborate and design applications, events, and schema, right? And catalog and publish them, publish high-value events as event APIs. Download AsyncAPI specification of these published events. At this point, all the tools that AsyncAPI has to offer can be put to use in terms of validation, code generation, and so on. And from that AsyncAPI, you can generate a Spring Cloud Stream projects that uses Solace as a binder, Solace PubSub Plus broker as a binder, to create a complete, ready-to-use microservice application that simply requires business logic implementation. The portal is a tool that helps the architects to design the entire EDA, starting with an application domain, which contains one or more applications, just acts like a namespace. And each of these applications in turn contain information about the events that it can publish or subscribe to, right? And as far as the events are concerned, the event schema, the underlying schema that a message payload is expected to carry at runtime is also specified here. Without writing a single line of code, this designer tool helps the architects to design the entire EDA all the way down to the schema level. Once this is done, the catalog feature kind of lists out the published, lists out all the available events and their associated applications with their topics, right? This makes it searchable and queryable and so on. And last but not least is the event API product. It is nothing but the identified high-value events in the EDA can be exposed for external access via AsyncAPI. You pick and choose the events from the EDA that you want to expose with the appropriate permissions for publish or subscribe and make it available as a downloadable AsyncAPI specification. And with that, the AsyncAPI takes over and start building code using the tools start building application, and straight away you just have to implement the business logic. Let's quickly review the smart town microservices design. So we have 3 microservices: a data simulator, collector, and aggregator. Right? Simulator is the one that simulates the sensors by publishing temperature reading. Right? And data collector subscribes to this temperature reading and produces operational alert. And aggregator is the one that's going to accumulate these operational alerts over a period of time and produce an aggregated alert with an aggregate temperature. Right? So in this case, when we completed the exercise of event portal, right? Let's take a look at this. We published an event API product. That API product is basically exposing these events with a permission set. In essence, temperature reading, if an external application wants to subscribe to it, it can. And if an external application wants to publish an operational alert to the broker, it can. So this event API product revolves around these 2 events with a permission set as permissions as described here, right? And this AsyncAPI specification is available. You can download from the portal. If not, you can. It's made available on a public URL. When you expand and see, you would get all the necessary details about the constructs that are part of the AsyncAPI specification: channels, servers, messages, and schemas. Right. So at this point, let's go straight into the Spring 2 suite, and we have pre-built microservices except for the collector. Let's review them. When you look at the Spring Cloud Stream project, at runtime, the behavior is controlled by this application YAML, or it could be application properties. It contains all the necessary information for the Spring Cloud Stream to operate the publish subscribe activity. Right. So you can see here, to begin with, the underlying binder, the type of binder, and then the environment properties for the binder to make the application to make a connection to the message broker, and so on. This will be specific to binder use. And then the bindings properties, whether it's a publish activity or a subscribe activity, depending on whether you see an in or out on the function name, and also the topic on which the activity takes place. Right? Anything above is just a plain Spring Boot startup parameters. Right? Let's take a look at the application file. This is a classic Spring Boot application. The only function that we added here is the bean function. Just looking at the signature, we can see that it's implementing this producer message exchange contract, right? So whenever it's invoked, it's going to construct this POJO, what is temperature reading, and appropriately populate attributes and publish it to the broker. Before publishing, it sets the header property called target destination and sets the topic name, which is constructed based on the city, latitude, and longitude values at runtime. Okay, so let's start this application and see where it goes. Sorry, it's running. I'm going to stop and restart again. So city IoT simulator, this is going to simulate temperature reading data being published. Yes, it is being published. Let's not worry about it. We will figure out a way to verify this. And then the next one is, based on the picture, what we see here is data collector. Let's park this for a moment. Let's go to data aggregator. This is also a completed service. Let's review that. So, right, let's take a look at the aggregator microservice. Let's review the application YAML file. So you can see the bindings properties calls out clearly both input and output, in and out events, message names, and the topics on which the publish and subscribe activity takes place. So the function name is aggregate temperature, and the binder properties are appropriately set, basically to establish connection to the underlying broker. Let's look at the application file. Just ignore the flux and mono use here. What we're saying here is we're going to get a sequence of operational alert over a period of, I believe, 10 seconds, and accumulate them, and then put it through a mapping process to calculate the average temperature. After computing such a value, we are going to construct a POJO by type aggregate alert, and then set it as a payload and publish a message to the broker. And the target destination is going to be the one that is as defined in the application YAML. Here it is. Aggregate alert created v1 and It's going to contain values like city, priority, and type. Right? It's going to be the analytics. All right, so when this event is published, obviously there will be some subscriber. And in our case, based on the picture, we have a dashboard application. In our case, we are going to be, again, building a simple web app that subscribes to this event on the broker via MQTT protocol and just plot them on a Google map. So that one, probably there's nothing big deal. We just need to run and visualize them. So what's the key thing here is the data collector. Let's go back to the AsyncAPI portal, where the event portal has published the event API product, and the corresponding AsyncAPI document is available for download from this location. It contains all necessary details, right? So with that, let's see if we can generate the code. Here it is. So I already installed the AsyncAPI code generator, and you can review the parameters here. The output folder, and then everything with the -p is a parameter. View is provider, binder is Solace, dynamic header type equal to header, artifact ID, package name, and so on, right? All these things put together, when you run this, it's going to generate a complete Spring Cloud Stream project. You only have to implement the business logic, basically the being function, all right? So in keeping in mind time constraint, I've already completed that. So I'm going to review that with you here. Alert generator, and you can see here in terms of application settings, it's pretty much similar to what we saw in other examples, and it uses the message exchange pattern, what we call as a processor. And let's look at the application. When it produced the code, probably it wouldn't have had any of these things. It would be an empty body, right? Now we have populated the business logic, basically to open up the temperature reading data and check the temperature and see what range it is in, and based on that, generate or appropriately assign the alert type and severity, and create a POJO operational alert, add it as a payload, and publish it to the specific destination, right? So now we know that it's already there. Now, before we run a completed one, let's start the alert aggregator. So the expectation is it should not be able to proceed much further because it's not going to get any events, right? So over here, we are running a simulator that's simply publishing temperature reading. And over here, we are subscribing to operational alert, which is not yet coming through, right? Only when operational alert comes, it can process and produce an aggregate alert. And this is the aggregate alert application window, alert generator. I'm going to run the application. Let's see. So it should subscribe to temperature reading. All right, there we go. Yes, it is getting the temperature reading data, and in turn, it's producing operational alerts. There we go. Now that when in a period of 10 seconds, it received 8 operational alerts, and from that, it was able to construct the severity type as high and alert type as high temperature, and publish this aggregate alert events. All right. Now this is the window where I can run the web application. This is going to subscribe to this aggregate alert and just plot them on a Google map. All right. Let's see. Unfortunately, there is an issue with the Google Maps key. I could not show it in a live map, but this is just a representational image. When I ran this program with multiple cities publishing their temperature data, aggregated alert data, we were able to see the severity and alert type all in one place. So pretty much what we have done is, going back to this picture, we took care of this one subset of problem of temperature monitoring and management, more specifically everything around microservices, using AsyncAPI and Spring Cloud Stream with Solace as the backing broker. Right. That brings us to end of this session. So I hope you were able to get a kind of big picture on how the Async API and Spring Cloud Stream work together to make this EDA building exercise easy and friendly for everybody. Thanks very much for the opportunity.
Um,
Yeah, I just realized, of course, that I was on mute.
yeah.
Yeah. So, thanks again for watching. Please let's make sure that you have some questions. Please share them in the comments. And because of delay, now people probably are in the phase where I'm speaking, but not they can't hear anything. So let's give folks a bit of a moment to ask questions. And in the meantime, like Giri, would you like to add something to the presentation, like some summary or something like?
Oh, sure. No, even though I took upon a simple examples that are already there in the Spring Cloud Stream, kind of a portal and Async API, I just want to set the journey, right? The Async API being not just a specification, but also a tool set. So you get a comprehensive coverage, in terms of being able to facilitate exchanges, creating repository, and sharing with the external applications and services, and also a tool to generate code for different frameworks. That is the exciting piece. Even though I chose Spring as the choice here, but we could be working with Node, Java, .NET, and whatnot, right? So that part was exciting. And last but not least, without the Async API, it is hard to envision a portal. The purpose of portal is basically to identify, curate, kind of a store and share, right? So the async API specification paved the way for bringing about this asynchronous APIs on par with REST API, right? So that was the exciting thing that I kind of went through. I will take questions.
Okay, thank
I'm
you.
sorry, somebody is making a comment. Wish I was better at reading lips. Yes, I realized there's a kind of a gap or lag between my video and audio. Sorry about that.
No, I think it was rather a comment to me speaking without while being on mute. So thank you, Greg, for noticing.
Okay.
Okay, let me check some other channels.
Yeah.
Okay, so far I don't see any. Okay, so thanks a lot for starting day 3 with your presentation, taking time to record this. I can't thank you for showing some Java code. I'm not a fan, but I think it's what is good that that actually that you did it. That also Solace is maintaining the Spring Cloud Stream template. That we have also Java tools here in the AsyncAPI tooling ecosystem. So thank you for doing it. And oh yeah, we have a question. What would you say are the biggest challenges with AsyncAPI compared to OpenAPI? It's a good question.
I'm sure, Lucas, you are more qualified to respond to that than me. But I'll put my 2 cents. I believe the async API is playing into the domain that involves a lot more than just asynchronicity, right? So having standardized things and kind of a community-driven scope of things, we could go beyond just the API. I believe the binders with various messaging systems, and then possibly that can lead into future features. Now, I don't want to spell out anything. That would be my requirement. But I believe from an OpenAPI specification, sorry, the async API perspective, Lucas, you might be in a better position how it could differ in a bigger sense, yeah?
I mean, I see it only from the perspective of the community that comes in, asks a lot of
Right.
questions about the spec, and also as a user in the past. But so basically, I don't see a bigger difference because both have to
Yep.
be written by hand usually, and the biggest challenge with any kind of specification is always this starting moment when you have to educate and learn it. It's pretty difficult, like pretty steep, and but yeah, Async API, we're trying to make it as easy as possible to start with the first Async API document. But yeah, I think for the user, it's super start to do something like start with a good example or something. So
By the way, I love the studio tool. So you don't have to hand code anymore. You have a visual interface. That's great, actually.
yeah. So that's the goal. So that's why we we try to solve these challenges, like with writing a YAML. Nobody likes it. Everybody is laughing at it. Like since Kubernetes came in, everybody are laughing at people that they are YAML developers instead of any other programming language developers. So who likes to write YAML? We just need to fix it for both Async API and Open API. That's at least
Yep.
my opinion. Any other questions? And of course, I on purpose did not talk about Async API and the publish subscribe confusion. I think it's pretty obvious.
I didn't want to open it. Just, yeah, fair enough.
Yeah. Is there another question? I see some new messages coming. There is a comment. Maybe you can do something like AWS did with CDK. Do you, Giri, do you know what it is? Because I don't really.
No, not really. No, I cannot comment too much on that.
So if you can jump in like super interesting topic for me. So Nike, if you can like jump in into our Slack, we can talk about it. Like let's see. And then I think, is there a question?
This question to you.
Can I how to in American movies? There's this like you have the right to remain silent.
Silent.
So yeah, I take the First Amendment, whatever,
Fifth.
and Fifth Amendment, sorry, and I will remain silent.
Uh,
Okay. So let us because we're running out of time. Next talk is in 6 minutes. So and you folks also need break. So thanks so much, Giri. We're gonna make sure also like folks in the comments and in the community that we're gonna address your questions. And Giri, if you can stay at this a bit, if there's some questions coming in, like please answer them just in
I will.
like by hand. Writing the answers, please. Thank you.
Yeah.
So yeah,
Thank you.
again, please, thanks a lot for joining the event. This time I, of course, unmuted first. Hi, folks. After a pretty short break, something important before we start our presentation. Have a look at the bottom. The event happens, among other things, but with support and great support of our platinum sponsors, Postman, Abli, WSO2, IBM, and Solace. But not also platinum sponsors. We also have a great golden sponsor, Red Hat. So thank you a lot for making it happen. The next presentation is from Ayush from Postman. And the title is Using AsyncAPI Schema to Define Event-Driven Architecture with AWS SNS. And let me invite Ayush before we start.
Hi, Lucas.
Hey, how you doing? Can you, like, before we start the recording, would you like to add something to the presentation?
I just like to tell everyone like this was my also first time working with event-driven architecture and SNS, and I tried to bundle whatever things I learned on the journey so that it can help anyone else trying to work on the same similar kind of things.
Okay, awesome. And some personal note from my side, like I'm also working for Postman, but interesting thing is that we never met, we never like worked together because like I'm on a AsyncAPI team, let's say, working fully on AsyncAPI, and Ayush is just exploring it as a user. So it's super interesting. I'm super interested with your talk, and let's see how it goes. Please, people, enjoy. We're gonna go to backstage and the recording is about to start.
Hello, everyone. I am Ayush, and I work as a software engineer in the integration squad at Postman. Today, I will be talking about using async API schema to define event-driven architecture with AWS SNS. As this talk is intended for beginners, we'll first start with defining very basics like what is an event, what actually is an event-driven architecture. Then we'll talk about what is AWS SNS and why is it useful. After that, I'll talk about what was the use case we had at Postman and how Async API helped us in solving our problem quickly and efficiently. So let's start with defining what is an event. So an event is any significant occurrence or change in the state of a system hardware or software. I'm adding hardware here because the changes might include from a separate IoT device to change of a sensor value or things like that. You might have heard about event notification in different contexts before. It is actually quite different from event because event notification is a message or notification sent by the system to notify another part of the system that actually an event has taken place. So it just acts as a message or a notification service for an event, as the name suggests. An event can actually carry in-depth context information of what has actually happened, or it can just have an identifier, in which case you have to call the necessary APIs to get more contextual data regarding the event. Let's come to what actually is an event-driven architecture. So it is an architecture which uses events to trigger and communicate between decoupled services, and it is actually quite common in modern applications built with microservices. So an event-driven architecture has three basic components. First is the event producer. It is the part where the event actually originates. Then we have an event consumer. The consumer is the part of the system that has to perform certain actions on the occurrence of the event and needs to be notified of new events. Now, the third is event router. So it is a connecting link between the event producer and the event consumer. In certain cases, it can actually also act as a filter and block certain events to be delivered to some specific consumers so as to not overload them with various unnecessary events. In this architecture pattern, the producer and consumer are completely separated from each other and communicates only through the event router. For example, we can take a simple system of Bitcoin price change notifier, which should send an email notification if the price is above a certain limit only. So in this simple system, we can have a simple cron job which fetches the current Bitcoin price using the necessary APIs, say every few minutes, and it has to send it to the router then. So it will be our event producer. Now we will have another service which sends out email notifications. So this secondary service will have only single job to send the email notifications wherever it is we have configured to. Now this actually will be our event consumer. Now we will define our router to publish price change event to email notifier only if the price is above the limit. And we might have a separate use case in which there's a third service which needs to be notified on every price change. So that could be our secondary consumer, and this is the reason why a filtering mechanism might be required on the router level. Now let's talk about like what are the different benefits of using an event-driven architecture. First and foremost is like parallel processing. So say on occurrence of an event, you wish to perform a large number of heavy actions. With event-driven architecture, you can execute them in parallel without any hassle. One can actually add separate consumers for the actions to be performed, and each will get triggered individually on receiving the event. This will actually also ensure failure of one action will not affect the another, which might occur if you're using a traditional synchronous system. Second is a versatility in choosing the technical stack. So since producers and consumers are completely decoupled in event-driven architecture, it allows the user to use different software stacks for both, and same hold true for individual consumers too. One can have a producer which is say using Python to generate the events, and consumer might can be written in Node.js for some optimization purposes. This is actually pretty useful in efficient working of complex systems too, like in which in which like say one part could be written in a high level language for better abstractions and support of better libraries, and another the consumer side could be written in a low level language for better performance and optimizations. Now the third we have is like hassle free cross team dependency. So to explain it, let's take an example. Say in a company there are three teams, A, B and C. They are already using event driven architecture to communicate, in which A publishes an event and B and C consumes them and performs some actions. Now, say if a new team comes, new use case comes for team D, in which it actually needs to perform some actions on the events which A is producing. Since they are already using the event-driven architecture, there will be no work required to be performed by team A. Team D just needs to subscribe to the events on the event router, and it can start processing the events effortlessly. Apart from this, event-driven architecture also allows producers and consumers to scale independently. So, if say the producer is getting a lot of traffic and a consumer is just triggered on very few subset of events, we can have much better scaling for producer, and we can have less number of instances for consumer. Now, let's talk about what is actually SNS. So SNS stands for Simple Notification Service. It is an AWS service which acts as a event router to provide message delivery from producer to consumer. It actually has an inbuilt filtering mechanism which allows consumers to get triggered only on the matching subset of events and not on all the events which are published, uh, which saves the compute costs for consumer a lot. The communication between producer and consumer happens via topic, which is the logical access point and communication channel for SNS. So consumer subscribes to a SNS topic, and whenever the producer sends an event to the same SNS topic, consumer receives it and performs execution. Because of this, SNS all topic also groups the set of producers and consumers together for easier maintenance. Let's see like how this actually works. So in this case, here is the producer, which will send event to SNS, and SNS can then forward this event to various different services. Like if the whole infrastructure is in AWS, it can easily send the events to Lambda, Kinesis data, SQS, HTTPS APIs, which you have. Apart from this, it can also actually send push notifications, email notifications, and say SMSs directly through SNS without using any other external service. Now, uh, I mentioned like the SNS actually allows you to filter messages. Let's take a look like how does that message filtering works on SNS. So when a producer publishes a message to SNS, along with the payload, it can actually attach some key value pairs to the message, which will be used in filtering. So point to note here is that you cannot directly use the payload data for filtering purpose, because SNS also allows you to encrypt that payload data for better security. So when the consumer creates a subscription with SNS topic, it can actually provide a optional filter policy to receive the subset of events. The filter policy will work on the attributes which the producer is sending along with the message payload. So the as you can see, the producer is adding some attributes. Consumer, while adding the subscription, tells like which for the value of which attribute should be triggered for this particular event to be sent to the consumer. So this filtering logic is completely Boolean. Either it matches the filter policy or it won't. So when it matches, it delivers the event, and if it is not, it just skips the consumer and checks on the next one. So for a particular message to match, so if in the filter policy you have added say three different attributes, all of them should return true for it. It's not like if you added three different subscription filter policy, three attributes there, and only one or two are matching and third one is not, it will not deliver the message to that particular consumer. The third point here is the attributes of the message not mentioned in the filter policy are ignored. So if say your producer is sending 5 different attributes, and for the filter policy we have only 3, the other 2 attributes will be completely ignored without any hassle. Also, the one thing to remember is the matching is exact without any case folding or any other string normalization. So you have to keep that in mind while adding the filter policy. Also, the number matching is done on the string representation itself. So 300 is not equal to 300.0. So this is a very important gotcha for this if you are working with SNS. Also, the value of each key in the filter policy, which we are defining on the consumer subscription level, is an array containing one or more values. So the policy matches if any of the values in the array matches the value in the corresponding message attribute. So if in the filter policy for a attribute A, you are setting the value of the arrays as 1, 2, and 3, and the message attribute has the value as 2, it will get matched. So, but if the value in the message attributes in itself is an array, then filter policy actually matches it if the intersection of the policy and the message attribute array is non-empty. This is how the subscription works. Let's look at a diagram to see like how this actually happens. So here, ignore this ingester for now. Say we have 2 producers, monitor and collection. They are 2 separate producers. Monitor sends event A and B. Collection sent event C. All these events, these are the message attributes attached. The attribute key is event type and event action. All those three different values are added. We have 2 separate consumers. SQS 1 is our first consumer here. SQS 2 is the second one. For SQS 1, we have defined the filter policy as this, like event type can be monitor or collection, and action can be monitor run finished or collection updated. Similarly, in SQS 2, the second consumer, we have type defined as monitor and collection, and action could be monitor updated and monitor collection updated. So when these 3 events reach at SNS, let's see individually what happens. So let's say first the event A approached SNS. So it will first match the filter policy, try to match the filter policy of first consumer. Event type, as you can see, it's monitor. Monitor is present in this array. It matched. Event action is monitor unfinished. Event action here is also monitor unfinished. It matched. So it will send the event A to SQS1. Now it will check for SQS2. Here, though event type matches, but event action is not present in this array. Hence, it will not send this event here. In case of event B, the type and action, which is monitor updated, the action is monitor updated here, matches for the policy of SQS1. So it will send the event B here for the first consumer. When it checks for the second consumer, again it matches. So it will send a copy of event B to SQS2 also. So producer sent the single event, and it gets fanned out on the consumer level at SNS. Similarly, in case of C, the filter policy at SQS1 doesn't match. but at SQS2 matches, so it sends the event C only to SQS2. So this is how the message filtering at SNS actually works. Now, I would like to talk about what was the use case at the integration squad in Postman. So we wanted to allow different teams to easily send relevant events occurring in their domain to us. Then we would then process those events and trigger relevant integrations. So as the producers can be large in number in our case, like different teams at Postman, we wanted the service to be completely decoupled, requiring minimal changes on their side for faster adoption and less maintenance for future. In future, we might actually need to add more producers to the service also. Hence, we wanted it to be easy and fast for the new teams to start publishing their events. So it should not be like they have to do a lot of development work to only enable the publishing of events also. Lastly, there could be other teams also which might want to perform some actions on the some of the events we are receiving. So to prevent them from reinventing the wheel, we wanted it to be easier for them to start consuming the events which we are using right now. So now I'll like to tell like different approach we used for the solution, and then I will talk about like what was the final approach we decided to go with. So this was the approach one. So here, ingester is just a small service which performs some validation checks and adds an abstraction layer to communicate with SNS. So all the different teams just send their events to ingester. Ingester validates and checks the event payload, adds corresponding message attributes, and then publishes them to SNS. Then SNS, at SNS we have like different queues for each team. At the end of the queue we had a router, and the router actually sits at the end of SQS, and it essentially works as a switch. So consumers will be connected to the router will be connected to the queue, and whenever an event comes at the router, it will check like whether which consumer wants to listen to this particular type of event, and then it will just fan out to those consumers at that level. So the technical stack I thought initially would could be a lambda sorts for the router. So there were a lot of issues in this whole design. First of all, there were problems with router, like constant update needs to be added on the router for any new consumer added or removing an existing consumer. Router needs to be updated. There would be added costs and maintenance overhead for the routers too. So that was a problem. Another thing is consumer has to know which particular queue and router it has to subscribe to. And adding a completely new domain, like let's say we have like 4 domains right now: collection, monitor, API update, team, activity. Adding a new domain would require a lot of infrastructure changes, like we have to add a new queue router connected to the SNS, which is very much hassle. So at the end, we finalized on this. So event producers will publish events to ingester. Ingester publishes those events to SNS. And after that, the whole infrastructure would be owned by the consumer. So if say consumer wants to add a queue, they can add an SQS queue, and then their consumption logic, they can add a direct HTTP API to SNS. And the filtering part would be completely owned by SNS itself. So provide more autonomy to the consumers as they can define how they want to ingest the events. Um, and as I mentioned, the filtering was done at since the filtering is done at SNS level, it removed all the maintenance overheads we had. So this is the workflow we finalized on to for our use case. Now, I would like to discuss like how Async API helped us. So one of the first and very foremost thing which Async API added in this whole process was easy review of payload and the event structure. So there was a separate team which will be generating the event. Then our team would be consuming those events. So the coordination needs to be precise here. So Async API helped in that. It actually allowed the producer and the consumer here, in our case, to start working parallelly without any dependency on each other. Then the API schema actually provides a one-stop repository for future teams also to so that they can check the event payload whenever they want to create a or add a new subscription, allowing faster adoption of this particular. schema. So wh- this is just a depiction like how what would happen, like could have happened if the async API schema was not present for us. The producer side might have been working on their side of changes. We might be working on our side of changes, and when it's finally time to merge both, uh, something like this could have happened. So async API actually helps us to avoid this kind of a situation. Now, I would like to define some essential components of the async API schema which we use. Uh, First is servers. So, uh, before servers, actually, there's a info block also, which is mandatory for the schema. It contains the basic information like the title, description, and the version of the API schema which you are using. Servers actually allow you to define like a different entry consumption or the entry points for the events. It will be using for communication. So this here production is just a reference or identifier for the server. Then we have the URL, like what will be the URL of the server. Protocol, we had like HTTPS, but you can use any supported protocol here, like HTTP, AMQP, MQTT, WebSockets, anything which you like. Description is just to define like what the server is, like whether it will be running in production, whether it is just for testing on stage, this kind of a thing. Then we have like security, like what kind of authentication it will be using. The basic auth here is just an identifier, which I used in my schema. How the security is defined will be coming on to next now. Security, so as you can see, this components, inside the components we have security schemes, and here we define like what type of authentication we want. So basic auth, as I mentioned, is an identifier. It can be anything ABC, which would be used in the previous slide if we used. Type, user password. So for me, the authentication scheme is user password authentication, but you can use various other supported authentication schemes like OAuth 2, API key, just to name a few. Like there are a lot of supported auth schemes which you can check out on the documentation page. And description is just self-explanatory to define like how maybe you can get the auth credentials, where to look for the auth credentials, or how it has happened, why it has happened, things like that. After that, we have channel and schemas. So first, let's talk about channel object. It actually holds the relative path to the individual channel and their operation. The path here would be relative to the server. It is actually known as topics, routing keys, event types, or paths also. This is the basic schema for the channel object. It looks like this. Like for the, it could be here the subscribe could be, let's say if it's a producer, it could be publish. Then message schema is defined in the separate component so that it's more modular. Then we have a schema object. So schema object allows the it actually allows you to define the input and output of the data types. It can be the object can it can be an object, it can be a primitive array, things like that. It can actually be directly used in the reference object like we are doing here in the channel object also. We are just add the path to the object and it will be directly used whenever you're, let's say, if generating the HTML or a markdown of a particular thing. So that's it from my side. Uh, this was the end of the talk. Thanks a lot for listening. These are my handles on different platforms if you want to connect. Uh, Thank you. Thanks a lot.
Okay, we're back from the backstage. I hope you enjoyed the talk. We have, as I said at the beginning, we have Ayush with us to answer questions. And there actually is one already. So the question is, how are event bindings defined for consumers using AsyncAPI to zero? I guess about bindings for SNS SQS.
Yes, so yeah, bindings are, as you all know, actually specific to the protocols. So in our use case, it was in pretty nascent stage, so we didn't explicitly use the bindings as of now. But yeah, for that, anyone can use the channel bindings to define.
Yeah, I can share with you there's a link. So there's a proposal from Ian Cooper, one of our community members, for actually SNS and SQS bindings. And like my personal thank you to you, Ayush. Like you explained SNS and SQS so well to me, so it's gonna be much easier for me because we see more and more people coming in asking about SNS and SQS. But if you don't interact with it, don't use it in production, it's pretty hard to really get an idea. So thank you for that. And the next question: how are consumer event bindings defined on AMQP channel? AMQP, but different thing than SNS, SQS. I guess, Jonas, you're asking general question. So, I mean, Ayush, you want to take it? Did you had a chance to use AMQP and look at it? Because, no, okay, it's
No,
fine.
actually, I have no experience with AMQP, so sadly, I could not help in this particular question.
Yeah, even I can't really. Would just have to take some time to really have a look. So Jonas, sorry, just be patient there in the comments. If there's somebody in the community that can already provide answer, please. I'll try my best later on, and if not, you can always go to bindings repo and feel free just to open a issue there with question about how to properly use AMQP bindings. Will for sure help you out. And no worries, no worries. It's just like just remember that we don't have always answers at the same time to provide them. But yeah, we'll surely help out. So no worries. Okay, any other questions? Okay, I don't see any on any channels. So yeah, oh yeah, there's some new message in there from Dave. Ayush, do you have an example SNS async API file you could look at? We could look at.
I do have the one which we created at the Postman for our internal use case. I have to check with others, like if I can share that or not. Else, like we can have a discussion with me on the Slack, like if you are having any specific doubts for the schema file.
Awesome. Like, remember you, where we work in the same company. So if you have some challenges in convincing people, let us know. We're gonna make sure that like just anonymize the data as much as possible. And but yeah, we need a lot of examples. So they've made a good point. And for SNS, especially when we will now work on this SNS SQS binding, would be awesome to have it. One more question. What interface would producers of events use to connect to SNS?
So the SNS actually has pre-built libraries for different languages already. So at Postman, we used Node.js directly. The ingester service which we had was the abstraction to connect to SNS. Or if you're using it in Python or any other language, you can use the REST APIs exposed by the AWS service itself.
Okay, thank you. We still have few minutes, if I count correctly, until the break. Like we can be here for 3 long minutes. If you have more questions, so do you need some follow-up answer? Oh wait, there's a comment from Tomasz. Hey Tomasz, and greetings from Poland. Does AsyncAPI support somehow documenting bridge configuration from topic to queues, like which SQS queues are subscribed to which SNS?
This also actually falls under the channel bindings object of the schema file, right, Lucas?
I'm not sure about like bridge configuration, what is actually meant here. So hard for me to answer. Like from topics. I live in a world of channels, so not sure how it really translates in SQS and SNS world.
So, according to the question, I'm assuming the SQS queues are here, the end consumers, the middleware for the consumers to connect with the SNS topics, maybe. So, I guess the channel bindings or the directly the messages for the consumer channels could be a way forward for it.
There is, I think, from some additional information from Dave. Let's see. So, oh no, it's a question. Wait, sorry, no. So let's not confuse people. So yeah, Tomasz, sorry, it's hard to provide answer. I can assume, but please try to like maybe ask it a bit differently, or just yeah, I don't know, try to provide some more explanation. But like to me, as I understand, whenever people talk about SNS, SQS, they usually talk about it like it's as a one thing. So not sure if really would you like to use AsyncAPI to describe these separately. So sorry. So let's follow up in the comments. And the last question from Dave. So will you be using AsyncAPI going forward for your new producer subscriber stuff in AWS?
Yes, definitely. We are already using it, and we will continue using the async API schemas to define the communications and everything for the producer and consumers.
I like your answer very much. And I encourage you to join the discussion with Ian about the bindings, because maybe now you don't need bindings. You probably don't have to generate code and stuff like that. But long term, I think it's going to be crucial for you. So just remember, there's this open discussion.
Yeah, definitely. I remember the link you shared on the Twitter thread itself. So
Yeah.
we'll definitely look at the PR.
Awesome, thank you. So yeah, it's time for 15 minutes break. Thank you a lot for listening, folks, and thanks a lot, Ayush, for not only taking time to record this session, but also come live and answer all the questions.
Thanks.
Yeah.
Thanks, Lucas. Thanks, everyone, for joining in.
Yeah.
Bye-bye.
And heading on to the break. Hey folks, welcome after the break. The next talk title is Sharing the Wealth, Socializing Kafka Event Sources in an Organization. And this time it is a presentation done by two co-speakers. It's Salma and Nick from IBM. Unfortunately, Salma could not join us live, but Nick is here. So let me invite Nick from the backstage.
Hi there, Lucas.
Hi, Nick. Can you hear us? Can you confirm that you have your video enabled? Because I'm not 100% sure.
I'm seeing myself on the stream.
Okay, cool. So yeah, before we start, would you like to add something to the audience about the presentation?
Yeah, certainly. So the context behind it is that we've been in IBM adopting AsyncAPI as a way of documenting Kafka sources. The ultimate intention is to provide the capability for customers to be able to essentially document the externals of their Kafka architectures. So to basically expose public topics, maybe they're created by internal topics, and you've got sort of this output piece. So rather than describing the whole application, the idea is that we can help customers to describe the external bit for other people in the organization to be able to consume. In order to do that, obviously, we chose AsyncAPI as a document, as an open document, as a way for documenting this. And then the idea behind this presentation is ultimately the challenges that we've faced whilst using AsyncAPI, along with the Kafka integrations. So just bits of the spec that have either been confusing or requiring human rather than inferring rather than becoming machine readable, and areas where we just need investment in the spec to be able to actually support a lot of the Kafka use cases.
Okay, thank you so much. So yeah, let us now start the recording, and Nick will be with us here also after the talk to address your questions. So get ready for some Kafka.
Hi everyone, thanks for joining us today on our talk regarding sharing the wealth, socializing Kafka event sources in an organization. Today, we will be talking about how we've been using AsyncAPI as a way to enable event source socialization. We will also be talking about the challenges that we've been facing with regards to some unique Kafka use cases when using AsyncAPI. My name is Nick Townsend. I've been a developer with IBM for 10 years, and for the past 4 years, I've been working on Kafka-based solutions. With me today is my colleague Salma.
Hi, my name is Salma. I'm also a software developer working at event and project management at IBM. So let's start with a story and talk about streetlights. So you might be familiar with this example, as is the same example on the AsyncAPI website. So we have Ava. She is a developer and she's just joined Smarty Lights. So Ava's manager has assigned her a task to build an application that will process the events that come from all the different streetlights in the area. And based off environmental conditions that those streetlights are reporting, the application will need to take an action, such as turning them off or raising a help ticket. So Ava thinks about it and she realizes the data coming in is essentially a series of sources of events. And so she begins to start thinking in a Kafka type approach. So Ava starts to build her application, but Ava soon realizes that there is no streaming data available for the streetlights. So Ava goes ahead and writes a Kafka connector that can connect to all of the different light APIs, pull in the data accordingly, and then push into Kafka. So this allowed her to run through some stream processing, make some decisions, and then start switching off the lights accordingly. So Ava knows Kafka, but isn't too experienced. And so it takes her a couple of weeks to get the application working, but she did it. But sometime later, Ava talks to Nico, and Nico is in a different part of the organization, but Ava mentions the work that she's doing, so creating this new application using Kafka, and talking about some of the challenges that she was finding. But Nico asks, why were you doing any of this? We already have a event source available in our Kafka cluster that is pulling in all of that data. So if you just had consumed from our topic, you wouldn't have needed to go through all of the setup that you went through. So Ava is now reasonably frustrated, and she realizes she has just wasted a lot of her time on this and wish she could have easily found out these topics existed before she spoke to Nico. So to try and help, Nico sends Ava some details about the application they have. He gave her an architectural diagram that explains the different producers and consumers that are involved in his application that ultimately result in some data about the streetlights being put onto the Kafka topic. So Ava has all these details about the internals of the application, but most of these producers and consumers means nothing to Ava. She isn't interested in that set of the data, and it takes a while for her to read through and understand it. But she finally realizes that she needs to look at one of the light topics. So now that she understands which topic she needs, she then gets on with the next part of the application. She no longer needs a Kafka connector and can go directly to Kafka to retrieve the streetlight data from the topic. But as she starts to do this, she realizes she doesn't have any idea of how the structure of those messages should look like. The format of the messages were not what she was expecting, and there was nothing documenting the schema. So Ava is feeling super unhappy and wishes that she knew what Kafka cluster and topics are available for her to use in her company. And when she finds the topics that she wants to use, how can she understand the data that is on them? And how can she start using these topics as efficiently as possible?
So we started to think, how could we make things easier? We've seen users and our customers facing these problems as they've been developing Kafka-based event-driven architectures. And we started to think, what could we do to help them? How could AsyncAPI allow us to enable a significant improvement to the user experience? As Salma mentioned, Ava was looking at the document and she was only really interested in the one topic. This could be considered an external API, an external set of data that Nico could have shared with everybody. He didn't need to share all of the internals, which risks confusing everybody. Instead, he just needed to document the fact that this topic existed, containing this data that other teams should be willing to consume. So instead of the impromptu meeting in the tea room where Nico and Ava had their conversation, what if Nico had actually published the information regarding this external topic to some form of catalog? He could have used AsyncAPI as a way to document the Kafka server. He could document the structure, and he could document any form of metadata that would be useful to explaining the particular API and data on that Kafka topic. Ava could later have then been searching through this catalog when she realized she needed to access the Streetlights API data. She would have been able to find that there was already a Kafka source available for her to use. Not only that, she could then have downloaded an AsyncAPI document, which would allow her to be able to start to configure her producers and consumers. Even better, by taking an AsyncAPI document, she would have been able to use a series of generated tools to actually build a bootstrap application that would consume the data from the topic. So at this point, she has simply been able to take an async document and generate client application. This is significantly easier than the workflow that we had Salma walk through earlier.
Well, we have implemented this scenario that Nick has just spoken to, and it's powered by AsyncAPI. So what this means is we are able to start rendering authoring experiences for both the developers and API consumers. We provide the capability of an API manager, as you're seeing on the screen, to allow users to document their Kafka topic using the AsyncAPI format, as well as being able to edit and publish it. So here you can see we have this form for users to fill out and upload to in order to create their AsyncAPI document with ease. And once they have created their AsyncAPI document, they then have the ability to edit their document. So editing their document allows them to add in more information. So as well as that, we also give the source view. So they are able to learn about AsyncAPI along with it. So we are using AsyncAPI as the document structure whilst authoring this API to describe Kafka. And in the same respect, we then use the published AsyncAPI document as a way to render a catalog where people like Ava can search and find them easily. So here you'll be able to see the AsyncAPI that was just created and has been published. So if we move on over to the portal side, and this is where we socialize the AsyncAPIs. So Ava will be able to easily search and find the API she is looking for. So we render developer-friendly features based off the contents of the AsyncAPI, and additionally we provide the document as a way for Ava to download, if she is a power user, to use the document with her favorite generator tools. So in this case, as you can see, we are generating some sample code for Kafka users.
Having shown you how we've been able to use AsyncAPI to provide the event endpoint management capabilities, the next thing is we'd like to discuss what's been challenging us today. So as part of adopting the AsyncAPI spec, there are some gaps when it comes to Kafka-specific behaviors. One thing I'd like to talk about is the idea of a Kafka bootstrap server. So Kafka is configured with a property called bootstrap servers, which is a comma-separated list of all of the servers that can be used for clients to initially bootstrap their connection. Kafka uses multiple servers as a best practice to allow for failover. This means that if a client is unable to connect to one of the bootstrap servers, it can then try a connection to another Kafka broker in the same cluster to ensure that we have failover and high availability. So looking at this snippet of the AsyncAPI document, we can see that there are two servers. It's named Bootstrap 1, Bootstrap 2. Both use the same security, both use the same protocol. So our first guess as a human reader would be that we probably should be able to combine these two into a single Bootstrap servers list when we write our Kafka application based off the specification. But what about these two? They have the same protocol. They have the same security type, but they have two different URLs and they have two different labels. They have a production and a test label. Now, to a human reader, we would assume production and test mean they are two separate servers. They probably are two separate Kafka clusters entirely. But this isn't obvious when parsing the spec. Those are just two labels. They have human metadata, but they have nothing to describe them for a machine generator to use. And then finally, we also have this scenario. Both the brokers have a similar looking label. There's different URLs, but that's not unexpected for a Kafka broker, especially if there was a load balancer involved. They both have the same protocol, but they don't share the same security. So the question is, how can we actually work to improve the spec to ensure that these kind of scenarios can be catered for? So there is currently an issue of open at the moment, issue 65, starting to discuss this. And the question is, do we look at perhaps grouping the servers by function, adding in metadata that allows us to identify when generating code, which server is in a pool, i.e. the same cluster, to be able to be used in a Bootstrap servers list? Or perhaps actually we take this in a different direction, and maybe we should be looking at using validation on the specification to ensure that we have a fixed combination of protocol and security. So by that, we can simply say, if there are a series of Kafka servers using the same protocol and the same security mechanism, then we assume that they are the same Kafka cluster and apply them to Bootstrap servers. But this is where we need your help. We'd like to accelerate this issue, but we aren't the entire experts. We want the community to help out. So if you have strong feelings about this, please could you start to contribute to the issue and help us to get through this challenge? The next piece I'd like to talk about is payload encoding. So in a specification, we can define the payload, we can define a schema for it. In this case, taken from the Streetlights API, we can see the 3 properties that are used in the message payload: an ID, the lumens, and the send-tap time. So what does this tell us? Well, it tells us the shape of the message, and it tells us the validation that will occur on the field values. We have minimum values, or we have a particular format. But we need more than this for Kafka. What we need to know is how this message ultimately gets stored in Kafka. And what do I mean by stored? Well, in Kafka, data is stored in bytes. So a producer will produce messages in byte stream to Kafka brokers, and a consumer will consume those messages as byte streams back from the broker and the topic itself. So the producers themselves and the consumers need to have a way to speak and convert words, data into a byte stream. And that's the concept of a serializer and a deserializer. So if a producer is configured to say that its payload will be sent through as an integer, then this serializer class is used to convert the integer into a byte stream. And as long as the consumer knows that it is speaking to a topic that has been populated with serialized integers, then the consumer can be configured to use the same deserializer and ensure it gets the right value back. But the problem is that if you can't communicate this, then the producer and the consumer could get in a point where they are using mismatching serialization library classes. So what this means is that if a consumer thought it was trying to get a string, it would be getting data back out of Kafka and serializing it into an object that made no sense. So given the previous example with our Streetlight specification, we know the shape of the message payload, but what we don't know is how it's serialized onto the Kafka topic. What we could start to look at using is the schema formats that exist in the AsyncAPI spec. By using the schema formats, we would at least be able to tell whether or not it was Avro or JSON or an AsyncAPI document that was used to create the schema and would be used by the producers and the consumers when converting from the byte streams. But this isn't the whole picture, because in Kafka, as I said, it was byte streams, which means not only do we need to know whether or not it's an Avro or a JSON schema that is being used to create the objects, we also need to know the type of encoding as it's being put onto Kafka, i.e. what will the serializers and deserializers look like? We could look at using the content type as part of the message. So if we said it was an application JSON, then we at least could infer that perhaps it's a string serialization of JSON going onto the Kafka topic. Maybe we could use application octet as a way to represent binary, meaning that in particular, say with Avro, it's actually being encoded in binary when it's sent over the wire, and therefore you need to decode it using an Avro binary decoder to get the message content back out. So what this means is that we could use an AsyncAPI document with a producer and with a consumer, parse the document, and look at the schema format and the content type. This would allow us to infer that we probably do need an Avro JSON serializer and an Avro JSON deserializer on the other end. But the challenge with this is that we are inferring a lot. So the question is, do the options for content type mean the same to everyone? Does application JSON mean I'm using the JSON encoding in an Avro serializer? Or does JSON encoding mean I'm serializing through simply a string? And the same with binary. Does the binary mean, does octet, sorry, as binary mean binary? Or does it mean something to anybody else? So our thoughts are perhaps we need to look at a Kafka binding as a way to identify the encoding. By that, I mean a specific Kafka binding on a message to give us a list of acceptable enums purely for Kafka. This would take away the ambiguity, and it would allow us to then ensure that producers and consumers could agree on the correct way to serialize and deserialize back from a schema object. I'm now going to hand over to Salma to discuss some further challenges that we're facing.
Right. Let's talk about schema registries. So Kafka uses the concept of schema registries, and a schema registry is a central place where producers and consumers can look up a schema, and they can use the schema as a way to serialize and deserialize objects onto the Kafka topic. But there's a problem. The producer and consumer need to know which schema ID should be used and when it wants to read or write to a message to Kafka. So in order to be able to go to the schema registry, it has to be configured with a schema ID. So we could use the $ref field as a way to define the message payload with a URL to point to the schema registry. However, with the $ref, you can identify where the schema is, but the question is, how do you communicate back and forth? Because although you have the URL, this doesn't actually tell you the vendor. So what is the API like? How do you know how to connect and consume from it? How do you write a producer and consumer that can speak to the schema registry in the right way to actually retrieve the schema? So to solve this, you will need to identify the vendor in a Kafka binding, but it also means you will need to write a custom producer or consumers for each vendor API. Well, actually, schema registries tend to come with their own clients for accessing this to solve part of the problem for us. So schema registry clients are already configured to know how to talk to a schema registry, and they are configured to know how to look for the correct ID in a Kafka message to be able to understand which schema was used to create it. However, there are multiple approaches to embed the schema ID information in a Kafka message. So in Kafka, an individual event is called a record, and a record is basically a key and a value pair. So keys are optional in Kafka, and so the bulk of your message goes into the value. So the key provides some additional information that Kafka can use for routing and things like that. So we would have this key and value, and there are two different ways in Kafka of how you can send across the schema ID. And one approach is embedding the schema ID in the record. This is using something called a magic byte. So imagine this is the bytes of a value of a record that has been put into Kafka, and the value has been updated. So it includes this magic byte. And what this means is that the producer sends this through Kafka, and when it is received by the consumer will be able to deserialize this message, and it will split it into three different parts. The first being the magic byte. So this is the additional bytes at the start of a Kafka message before the serialized data. So this magic byte will be a way to identify that this will be containing a schema ID. And the second part provides the integer schema ID. So this is a way to uniquely identify the schema that is being used for the message. So when the consumer receives the message, they will use this ID and they will go fetch that schema, and they will use that schema to go and deserialize the message. And then the final bit is the rest of the data. There is an alternative way to send the schema ID, and this is with record headers. So as mentioned before, in Kafka, we have a specific record, which is made up of a key and value, and Kafka have also recently added a record header. So this is the concept that has been included in a lot of different messaging systems over the years, and it's this idea of having additional metadata that can pass through with your message. And so the client will be able to read the schema ID from the header and retrieve the right schema from the schema registry. The problem is, however, different schema registry vendors have made different decisions. So looking at Confluent, they encode the schema ID using magic byte format, placing 4 bytes into the byte stream before the encoded data. Apicurio, however, have 4 different ways of approaching this. They either allow you to put it in the headers or allow you to put it into the message. But in addition to this, they also have 2 different ways of storing the ID, and one is an 8-byte long and one is a 4-byte integer. So how can we solve this problem? Well, we need vendor-specific bindings to be able to identify configuration for the vendors. So although you can say download the Surdies client, you will still need to know how to configure it. So is it speaking to headers? Is it speaking to the ID? These are the vendor specifics that will get put into the spec.
So in summary today, we've discussed how socializing events will save Ava time, effort, and sanity when consuming from Kafka topics and discovering new sources of data. we've shown how we've been able to use AsyncAPI as a way to provide an endpoint management capability that results in governed catalogs of sources of Kafka data for users to discover. But as we've also discussed, AsyncAPI does need to evolve to enable us to reach the full potential of these Kafka events. There are Kafka-specific features that need consideration in the specification, as we've highlighted today. So hopefully, we've been able to communicate our concerns and our ideas for the future, and we would really appreciate your help in fleshing out some of these issues and contributing additional ideas to allow us to get these capabilities added into the AsyncAPI specification. So thank you very much for your time, and we will now answer any questions that have been asked on the chat.
Hey folks, welcome after the presentation. Thanks a lot for watching. So please keep questions coming. We have this delay between the talk and the streaming platforms, so we are aware. We're gonna wait. And Nick, in the meantime, regarding this last challenge and the schema registry related, and that vendors have different ways of handling things with schema registries, does it mean you're looking into having a binding inside a binding, so vendor specific information?
Yes, that is a very good point. It could potentially end up that way. I mean, I think the challenges that we originally faced. So if you actually take, there's two sides to it. There is the requirement to be able to articulate the schema registry itself, i.e., here's the URL, here's where you would need to connect to, here's the Surdies client you would need to use to actually deserialize and retrieve the schemas. The other side, which is one bit we were interested in, was to say, well, actually, let's assume there's a scenario where actually the schema registry itself is protected. So, and as a result, for some reason, you don't want read access either to it. What we were thinking was that the vendor information of at least being able to identify where the schema ID is and where the, in particular, where the schema ID is encoded into the message. By having the vendor information, you then have the ability to say, okay, I know that the first 8 bytes are going to be the schema information. I can strip that off in my generic consumer and use the schema that's been provided in the AsyncAPI as a way to actually reinflate the message, essentially. And so that's where the vendor becomes useful for that generic case, because you can understand whether or not you need to be able to skip those bytes. Now, I would argue that in that generic case, you don't actually need vendor-specific pieces. You just need to be able to state there is a schema and it is the ID is encoded in the first X number of bytes. That's essentially just a flag to say, you don't have to worry because we've given you the schema in the document, but when you're consuming, skip over these bytes and then you can carry on deserializing from Avro accordingly. But you are correct that in the more, I'd say, useful use case, which is where you are actually allowing and assuming that the user of the API will connect into your schema registry, that's where you will need some form of vendor-specific data, whether that be just configuration. So it could potentially be an empty, a free-form text field where you just define your configuration that's needed to pass into the consumer, to pass into the Surdies client. Or you could have more structured, yes, this is a Apicurio schema registry, and it's an Apicurio Surdies client with these settings to it. And I think that's where it's, a question of, do we want to try to attack it with a generic-esque method or with vendor specifics? At a bare minimum, you just need to know ultimately the vendor of the schema registry, so that you can pick the right SERDs, then whether you get more specific in terms of configuration depends purely on whether it becomes then just a freeform config file or a additional set of bindings to say, well, actually the message headers here, it's using this number of bytes for it. But again, I think the configuration could still be generic Kafka bindings. It could simply be schema ID in the header. Schema ID is in the message. It's this number of bytes. But then you would infer, probably comfortably, could infer that as long as you knew the vendor of the schema registry. But I think that the bit we can't get around is we would need to have that vendor information as a single binding or as a single field to identify.
But looking at it from different perspective, like there's this CNCF working group called Serverless, I think, that handles CloudEvents. And I saw that they have this project, like provide also an API designed for schema registries. So basically all the providers of schema registries should follow the same API structure. Wouldn't this be also a different way to solve it? Like, of course, more complex because then all vendors have to follow. But I guess that's also a way, right? I'm not sure if you were familiar with this.
I'm not, but that's something I would definitely look into. You're right there that actually, if all the schema registries had that same contractual agreement, it would, from a spec perspective, simplify this significantly. I guess the only quirk perhaps would be whether or not there was something special in the individual vendor libraries. But yes, I fully agree. In an ideal world, if every vendor was using the same contractual APIs structure, then one assumes you could just pick any client that you wanted and it would be able to retrieve, and therefore you don't need that vendor information. You just need to know there is a schema registry, use your favorite client for it, because they'd obviously all speak the same APIs.
Yeah, because I'm thinking about it because I know that many people ask about it. Like, and many people talk about how AsyncAPI plays with schema registries. So obviously it's becoming a, maybe not a standard yet, but many people want to keep schemas in schema registry. And therefore more and more vendors enable that. And obviously it can, if it's not standardized quickly enough, then of course the problem will grow. But I recommend you to have a look on it. It's I think it's the same group of people that handle CloudEvents, and I think it was initially the first pull request, the first initial design of the API was, I think, by someone from Microsoft, and I saw that Microsoft Azure released this schema registry, probably for some serverless solutions that they have in Microsoft, but maybe they already did it by following this API. So yeah, might be also a good way to take it further as well.
Wonderful. Yeah, no, that sounds very interesting. Thank you.
No worries. So we're chatting, and I forgot to look into the comments. Sorry, folks. Any comments? Did we lose connection? Something? Can you please confirm that there are no comments?
I'm certainly not seeing any comments yet.
Okay, but at least
we have feedback.
So yeah, let me show it for others who felt annoyed by our discussion. Not everyone were, so thank you. Okay, so so before we finish, I'd like to also remind you folks something super important that Salma and Nick showed during the presentation was call out to action to support and discuss a specific challenge in the spec and how to solve it together. I'd like to remind you that on the day one of the conference, we had a contributor summit, and one of the presentations, and I'm not promoting my talk, it's just important for you to know that there was a presentation about how to contribute to the specification where we explained how to do it, that it is definitely something we encourage you to do. So yeah, as you could see, there are some challenges, and we always need a like collaborative discussion with people from different companies, vendors, and users to really yeah have good things in the spec that will solve not only one use case but also others. So yeah, thank you, Nick, for doing it in the presentation, and thanks a lot for delivering the talk. Please send hello to Salma as well.
Certainly.
And I hope that Salma, when you will watch the recording, thank you a lot, Salma, as well for delivering the talk. Sorry you couldn't join. Thank you, Nick, for being here. And we will have now a short break. Again, I think it's going to be 15 minutes or actually 25 minutes. So yeah, and do you want to add something at the end, Nick?
I think the main thing I want to say is that we, in terms of adoption, have really been very happy with AsyncAPI. It feels very natural coming from an open API world. I think the scope of what AsyncAPI wishes to cover, especially when you start looking at actually thinking about a full event-driven architecture, it's bold, it's brave, but it's doing the right thing, and the community is really, really enjoyable to be a part of. So I think we've got something really good on our hands, and yeah, I just look forward to seeing it as it evolves through into the future, into the next few versions.
Thank you. So with this good and nice words, let us finish for now, and the next talk in 25 minutes. Let me count quickly. 30 past now, 25, it's 55. Okay. And so in 25 minutes, we're back for a presentation from Nadja from Novatec Consulting. So, and it's about mastering schemas. So yeah, and I guess that we will talk about schema registries again. So stay tuned. Cheers.
Thanks, Lucas.
Welcome, folks, after the break. Hope you enjoyed it and get ready for another presentation. The title of the presentation is How to Master Schemas and AsyncAPI with Registries. And it will be delivered to us by Nadja from Novatec Consulting. So let me invite Nadja because she is here with us in the backstage.
Hey, Lucas.
Hey, welcome. Before we start the recording, would you like to introduce somehow the presentation, say something before we play?
Yes, I just wanted to add that the context behind this talk was that I was working on a proof of concept on how AsyncAPI can be used within projects. And I hope that some of the findings and ideas that are summarized in this talk will help others who are currently exploring and adopting AsyncAPI in their own projects.
Awesome. Thank you. So everyone, watch it carefully.
Everybody, my name is Nadja Hagen from Novatec Consulting. And today in my presentation, I want to talk about how to master schemas and AsyncAPIs with registries. So I want to talk about how you can use schemas like Afro schemas and AsyncAPIs within your projects, and how registries like the Conference Schema Registry or API Registry can help you within your projects. So let's directly start. In most projects, we have an architecture which looks similar like the simplified picture. We have an event streaming platform, for example, like Apache Pulsar or Apache Kafka. And we have producing applications that are sending messages to this event streaming platform. We have consuming applications that are retrieving those messages. And at some point within your project, you probably will face some problems. For example, that your producing applications are using a different message version than the consuming applications. And then you will probably decide to introduce something like a schema registry, for example, like API registry or the Conference Schema Registry. And then all the producing applications and the consuming applications will register their message schemas there and will also retrieve their message schemas from this schema registry. And for those of you who are not familiar with schemas or schema registries and why you should use them, I want to give a short introduction of the advantages of schemas and schema registries. So first of all, as I already said, it increases collaboration between different teams. So I also already gave the example of 2 teams, and imagine one team is moving the application to a newer message version and the other team doesn't know about this. And then maybe applications fail, and all those problems that come along with just upgrading the version could be solved with using a schema registry, which acts as a central access point for all the teams and all the applications. So all the applications can get the newest version of the schema from the schema registry. The next point is that you can avoid that wrong data is sent or consumed. So applications can reject wrong data that is not along the schema even before it is sent or before it is processed by the application. And the last point is that you can reuse schemas for different applications. For example, you don't need to redesign schemas that already exist and that are often used within a project. You can simply use one schema and maintain and manage it within the schema registry, which acts then as a single and central access point. And all this enables schema evolution, so you can move onward with your schema versions, and those newer versions can be managed by the schema registry and can be distributed to all the teams. And of course, there are also some downsides. For example, when you're in an early phase of a project and you want to move on fast with your schemas and you want to move on fast with the development of your applications, then maybe schemas and schema registries may not be ideal at this phase of a project. But for most projects, schemas and schema registries will be necessary at some point. And now that we have a message schema which defines the payload of our messages, we still don't know where should we send those messages to. And at this point, the API contract steps in to define the endpoints and the endpoint specific details, for example, authentication. And of course, also the message schema should be included within the API definition. And as we're talking about event-driven architectures, AsyncAPI is perfectly suited to close this gap. So AsyncAPI can be used to describe the whole API contract, and other schema formats, for example, like Afro, can be included within the AsyncAPI definition. And AsyncAPI supports to reference and to include Afro schemas, JSON schemas, and Rumble schemas. Other custom values are also possible. But the most important ones, Afro schemas and JSON schemas, are fully supported by AsyncAPI. And I want to show a small example how this could look like. If we switch here to the playground, you can see we have an AsyncAPI definition, a simple example which is inspired by the AsyncAPI streetlight example. We have a channel which is called light measured event, and a subscribe operation can be performed, and all the messages that will be published on this channel will have this format. And the playground also renders this documentation. You can also see how the schema of the messages will look like. But you can also see that including the schema within the AsyncAPI definition doesn't look that nice. So especially when you have multiple schemas within one AsyncAPI file, then the AsyncAPI file can become quite long. It becomes a bit messy. And of course, you could also extract the schema and include it in a components block at the end of the file, but still it's not really ideal. And for this reason, let's switch back to the presentation. For this reason, it is a good idea to separate schemas and AsyncAPIs. And there are multiple situations which could be possible why you should consider separating schemas and AsyncAPIs. First of all, maybe you're already using a schema registry within your project, and all the applications which are already using a schema registry should continue using the schema registry and retrieving schemas from there. And additionally, you do not want to document and maintain the schemas twice. So you do not want to maintain and manage the schemas within the schema registry and within an AsyncAPI file. And there are also a lot of tools which you may be using within your project. For example, the confluent serializers and deserializers, which need to schema registry. The next point is that schemas and API definitions probably should be independent, because you maybe want to develop your schemas independently from your API definition. And the last point is that during development, of course, you need the AsyncAPI definition and you need the schema definition. But during runtime, the clients only need to retrieve the schema from the schema registry, and they do not need the whole API. So otherwise, the clients would have to extract the schema from the API file to then process the message schema. But this is just not needed. They only need the schema definition from the schema registry. So how could we now solve this? How could we separate schemas and AsyncAPIs? The AsyncAPI specification offers the possibility to use external references for message schemas. And like this, the message schema can be stored and managed, for example, within a schema registry, but it could also be located within a GitHub repository or in any other kind of place where you want to manage it. And within the AsyncAPI file, you can then provide the link, a reference where the schema is located. And I want to show you how this would look like in the example. So we want to replace this schema here with an external reference. I simply delete this and include a link, a reference to an external schema. And as you can see, the playground will render it. It could resolve the external reference and could include it within the documentation. And now the AsyncAPI definition is much shorter, much easier to read, especially when you want to use it multiple times, or if you have a lot of different schemas within one AsyncAPI definition, then it looks much better and is much easier to read. Now here, the schema is located within a GitHub repository, a public GitHub repository. And this now only works because no authentication is needed. If it would be a private GitHub repository, then the React component would not be able to resolve this. But for resources where no authentication is needed, the React component can resolve it and include it within the documentation. Now let's switch back to the presentation. Now we know how we can use schemas within AsyncAPI files. We know how to manage them with the help of schema registries, but there's still one problem which remains, and this is how to manage our AsyncAPI definitions. So the problem becomes more clear when you think again about multiple teams working together, and then there are a lot of common questions which will occur. For example, which APIs are available? Who is responsible? Which team do I need to ask if I have any questions? Which kind of authentication do I need to use this API? So we need some kind of central API catalog where different projects and teams put the API definitions into. And in general, AsyncAPI, the AsyncAPI specification can help to answer all those questions, but the definitions need to be available for everybody who's interested to make use of the potential of the specification. To summarize all this, the requirements of an AsyncAPI registry on AsyncAPI catalog are that we have some kind of overview. We can browse and search all available files. We need versioning, not only storing different kind of versions, but also pointing out breaking changes. And we need to differentiate between different stages. For example, which API is valid on dev stage, which API is valid on pod stage. We also need rendering. So the YAML files should be used to generate documentation. This is especially important for non-technical team members, but also nobody really likes to read YAML files. And we also need filter options, for example, to search for specific team names or to search for protocols like Kafka. And last but not least, of course, we need to include external references. And those need to be resolvable and should be included within the AsyncAPI file then to generate the documentation. If the external references would not be resolved by the registry, then the documentation would just contain a link and would not provide that much information. So just like with the React component of the AsyncAPI playground, we need to resolve the external references. And to give it some kind of a spoiler, not all these requirements can be met at the moment, but there is one tool which partially enables to use these features. And this tool is API Registry, which is an open source project sponsored by Red Hat. And it is a schema and API registry. So you can not only register your AsyncAPI files and your OpenAPI files, but also your Afro schemas or your protobuf schemas. And I later will also show you how API Registry looks, how you can use it with AsyncAPI. Now let's move on to the big picture. I implemented a proof of concept, which includes all those components to test how they play together. And I implemented a streetlight application using Kafka Spring, which produces and consumes messages to and from Kafka. The application implements the streetlight API that you already saw in the example before. The streetlight API is, of course, documented using AsyncAPI. The AsyncAPI file will be registered in API Curio. And the streetlight application uses Afro schemas, which are registered at the Conference Schema Registry. And now when you think of maybe new applications that should be added to this architecture, and maybe another team is responsible for those other applications, then the other team can simply browse the catalog within API Curio. They can look which kind of APIs are available and which kind of schema will be used. And then they can develop the applications against the specification. Now, this is the overall picture, but still the question remains, especially for developers, how can we deploy our AsyncAPI files and how can we deploy the Afro schemas? And one possibility and one approach to do this is to use a GitOps approach. So first we write our schemas and AsyncAPI files, then we push them to a GitHub repository, which only contains the schemas and the APIs. It's also possible to create merge requests, reviews can be done, and if all the checks and all the reviews pass, then the new versions will be included within the main branch, and then a GitHub Actions pipeline will be triggered and will run and will deploy the Afro schemas within the Conference Schema Registry and the AsyncAPI files within API Curio. Now I want to show you how all this looks like. Here you can see the GitHub repository where all the schemas and AsyncAPI files are published to. Here are the AsyncAPI files in different generations. We have one major version and different generations, and each time a compatible change is made to the AsyncAPI file, a new generation will be published. So if we would now do a new compatible change, we would have a generation 5. And if we would do an incompatible change, we would have a new major version 2. And we have the same for all our Afro schemas. You can see we have different types of Afro schemas, and here's the same different generations for one major version. Then here are the GitHub action workflows, which deploy all the schemas and AsyncAPI files to the Conference Schema Registry and to API Curio registry. Then let's switch to API Curio. Here you can see we have an overview where all the APIs and schemas are listed. Currently, we will only have our streetlight API. Here you can see the content of our API, as you already know it from the example. You can select different versions, all the versions that we also have in our GitHub repository, which were deployed into API Curio by the pipeline. And as you can see, the AsyncAPI file is not rendered into documentation. So it could be an idea to, for example, include the AsyncAPI React component to generate documentation and to render the AsyncAPI file to make it more readable. And I also saw that there is a GitHub issue to support something like this, something like documentation generation. If we scroll down to our external reference to the Afro schema, we can see that this Afro schema is unfortunately not resolved. And if we would use the AsyncAPI React component, this reference would also be resolved and then displayed. The schema would then be displayed within the documentation. Now switch back. Here you can see that it is possible with API Curio to define different validity and compatibility rules. Unfortunately, as far as I know, and as far as I tested API Curio, for AsyncAPI, it's currently not possible to define compatibility rules. It's displayed here, but it currently does not work correctly. And there also is a GitHub issue to support this feature for AsyncAPI, but it would also be a possibility to include the AsyncAPI diff library to enable that breaking changes are displayed, or to enable backward and forward compatibility checks. And as you can see, API Curio already enables a lot of features and provides a perfect basis to implement additional features specifically for AsyncAPI on top of it. And it also provides a possibility to include other AsyncAPI projects within API Curio. Then let's switch to the Confluent Cloud. You can see the schema registry in Confluent Cloud. All the schemas are deployed by the pipeline within the Confluent Schema Registry. Here are the generations that I showed to you. And now I quickly want to show you how it would look like if we now would deploy a new schema version and a new AsyncAPI version. You can see this is the oldest generation of our Afro schema, and we now want to change it to look like this. And as you can see, we changed a lot, and therefore we need a new major version, version 2. And we also, of course, need to change our AsyncAPI, and therefore we also need a new major version for AsyncAPI. And as you can see here, this AsyncAPI will now reference the new version 2 of our Afro schema. Let's have a look if it works. We can switch back and we will see that the GitHub action workflows are now running and deploying everything in API Curio and in Confluent Cloud. And then we can have a look how it looks now updated in API Curio. As you can see here, we have a new major version of our API. It references version 2 of the Afro schema. Let's switch to Confluent Schema Registry. And if we update this here, then hopefully it will show version 2 of our schema. So that's it, basically. Thanks for watching. Thanks for your attention. And if you have any questions, feel free to ask. Thank you and enjoy the rest of the conference.
Hey, welcome back after the presentation. Thanks a lot for watching. And as usual, please start asking questions now. And before we start getting questions, because we usually have this tiny delay between the studio and the live stream, question from my side. Did I see correctly that the Avro schema that you had there followed CloudEvents spec?
Yes, I think so. It should follow the CloudEvents spec, right?
Okay, good. Yeah, like nice to see all these things like play together, like AsyncAPI, CloudEvents, schema registries. Awesome.
Yeah,
Awesome
that
stuff.
was also the goal of this implementation, to look how it can play together.
Yeah. And I'm not sure if you watched us yesterday, but yesterday, I don't recall the name, of, unfortunately, of the person and the talk during which the question was asked, but there was actually a question from the audience about AsyncAPI and schema registries. And like you perfectly add with this presentation. So thank you.
Yes, I also thought that it would be a common use case to use schema registry and AsyncAPI together, and how it could be integrated.
Yeah. And not sure if you could see like the ending of the session with from Salma and Nick, but I also stated there that like people come and ask all the time about schema registries. So Nadja, I know that you wrote this also an article about it. So if you'd like to republish it on AsyncAPI blog, because if people look for it, it would be good to have it there as well. We accept guest publications, even if it's repost. So please consider.
Yes, this would be very cool. Thank you.
Okay, I think we have a question. Let me try to display it. Not this one. Wait, this one. So, not sure to understand where API stands. AsyncAPI seems to be capable of resolve the schema reference, while API doesn't. And then, on the other hand, API is a schema repository like Confluent. Some follow-up statement. You also showed Confluent.
Yeah, I think what the person means is that API was not possible to resolve this external reference, even when it is also a schema registry. But I think the reason it's that it couldn't be resolved, that this Afro schema that was referenced was located in GitHub and not within API. And I'm not completely sure if API is possible to resolve references within API. I would have to test that, but I think it's not possible currently. And that's why I also stated that it would be an idea to include, for example, the AsyncAPI React component, which is capable of doing this.
I think I did some investigation about API in the past. As far as I remember, they are not using AsyncAPI parser. I think API is Java-based, and might be that they just have their custom parser, which just does not support dereferencing, and therefore that's why it looks like this. But yeah. You also showed Confluent registry on your diagram. What was that for if we already use API?
The use case was that in many projects are already using the Confluent Cloud, and then you are probably also using the Confluent Schema Registry. So all your applications are still using the Confluent Schema Registry. So you're probably maybe also using the Confluent serializers and deserializers, and you do not want to change your applications just because you now want to introduce AsyncAPI and API. So your application should keep using the schema registry. And that was the reason why I used in the diagram the Confluent Schema Registry and API, because, yeah, as I already explained, we want to keep using Confluent Schema Registry for our Afro schemas, but we need something else, another tool which is able to support AsyncAPI, which would be API.
Makes sense. Thank you. Any further questions? Let me check other channels.
And I also saw that somebody posted the link to the GitHub repository in Slack. If anybody of you wants to have a further look on how we implemented it, then the link to the GitHub repository can be found within Slack.
Yeah, thank you, Sergio. And also don't worry, like the recordings, even though we are doing a live stream, and the recording of the live stream will be available right after the conference. Also later in the following days, we will release every single presentation separately. And we also received links and slides from presenters, like from Nadja, and the link to the slides will be in the description of released presentations. So all the materials will be on AsyncAPI YouTube channel. There is a question. What about the support of protobuf schema in AsyncAPI?
I think that's a question that should be answered by you.
Yeah. I mean, it's a hard question. So it's a question people use quite often. but there's just a technical issue related to JSON. But I would not sure if there's Jonas and others now in the chat. So let me try to quickly find a related issue, or maybe Maciej, if you are there, please share a link to the specification issues in the specification repo, where we actually discuss how to enable things that are not so friendly for JSON and the referencing. So basically, protobuf or XSD schemas. So that would be answer that there's ongoing discussion, but also please remember it's an open source project. So if it's not on my agenda or some other folks, you can always push it into the spec. We just need to find a good solution how to make these things work together. So it's not that we don't like protobuf. Any other questions? Oh yeah, and Sergio just pasted a link to the to the issue. So please, let's keep chatting about it. Okay, looks good. So I don't see any more questions coming in. So Nadja, again, thank you so much for taking time to record the session, to come in, also writing about AsyncAPI before. Look forward for an article in AsyncAPI blog. And yeah, any final words before we come into the break?
Just thanks for the opportunity. And that's it. Thank
Awesome.
you.
Thank you for being here. And folks, yeah, it's a time for changing time zones. People in US and other parts of America, please start getting ready, getting your coffee ready. In 1 hour after the break, we start again with 4 additional presentations. And the first one will be, again, kind of continuation of what Nadja started talking about. There will be something about CloudEvents and a pretty good presentation from Laurent. So yeah, stay tuned and see you in 1 hour. Thank you. Hi, folks. After the long break, I know that we were supposed to start in 6 minutes, but in 6 minutes, we'll start immediately with a new presentation from Laurent. But before that, because of the longer break, some people, because of the late hour in one part of the world, might already finished, and some probably joined just now to the conference. So I'd like to share some general information about the event, so you know how it goes, how it runs. So first of all, please do remember that the event is live streamed to different platforms, and they all have chats. So it's pretty hard to navigate, I guess. So don't worry about it. If you're using YouTube to watch the presentations, just ask your questions there. If you're using Twitter, just tweet about it. If you're using Twitch, just put comment in Twitch. There's a group of amazing people helping out run the conference. They're checking all the channels and making sure that presenters and the person that introduces presenters know about the question, so we can address them. So don't worry about that. Also, these awesome people also share important links with you sometimes. So, for example, when the presentation finishes, they will share a link to a feedback form about a given presentation. They will also share link to code of conduct. So yeah, please remember to respect each other. But I'd say it only because I just want to make sure that I say it. But the community here is amazing. Nothing bad happened so far. So I'm not reminding you to be respectful because you're not. I'm just doing it because I have it on my list. Other links that people will share is surveys. So we have two feedback forms for you. Please take time to fill them in. One just have 4 questions. It's about the AsyncAPI, and one question is specifically about the conference next year. So please take time to, whenever somebody will paste links, please, take just less than a minute to fill them in. One is about AsyncAPI in general, and one form is about the AsyncAPI brand. So please take this 1 minute, and for us, it's really a lot. If it comes to presentations, they were pre-recorded, but our presenters are still with us. So they joined before we played the recording, and they also join live right after the recording to answer questions. So don't worry, we're playing recordings. It was mainly to make sure that there will be no technical difficulties. But yeah, presenters are still there to address your concerns. What else important? Yeah, the last presentation that is scheduled for today, because remember, day 3 is the last day of the conference, and the last presentation was supposed to be delivered by John. The topic was going beyond REST with AsyncAPI in the enterprise. The talk will not be delivered, unfortunately. We're in contact with John, so we'll try to share his story just on different channels. And in exchange for this talk, we had a pretty cool, amazing response from the community when we noticed that we won't be able to host this presentation. And we asked people in the channels how we could proceed, and we got an answer from Greg from Solace, who managed to record quickly a really good presentation about the event discovery tool that he saw for the AsyncAPI hackathon. So that's, I think, amazing stuff. So don't worry, we will still have 4 talks now after the break. So stay tuned also for the last one. And last but not least, all the talks were pre-recorded, but today, after the presentation from Laurent, we have a pretty special presentation. It's going to be a panel discussion about the future of AsyncAPI, hosted by Fran, the founder of the specification, with some special guests. So it's going to be a live session. So definitely please interact with the panelists, ask questions, and especially that today is a 5th anniversary of the project. Now, let me check my shortlist. Oh yeah, the most important, the sponsors. So the whole event, except of the list of amazing over 60 people that helped to organize the conference. So let me quickly share a screen and show the list to you. So yeah, except of this list of awesome over 60 people that contributed to organizing this event, we also had some companies sponsoring the event and also the hackathon before the event. So the platinum sponsors were Postman, Abli, WSO2, IBM, and Solace. We also had a gold sponsor, Red Hat, and also a platinum, a silver sponsor, SmartBear. So thanks a lot for all the donations, because they helped a lot and enable us to share some goodies with the hackathon and the conference participants. And with these final words, let me now invite Laurent to the live stream.
Yes, I can see.
Laurent.
Hey, Lucas.
So before we play the recording, would you like to, introduce somehow your presentation?
Yes, thank you. Thank you very much for inviting me today. So this is a presentation about a question I regularly met on the field. That is, should I use AsyncAPI? Should I consider CloudEvents? Should I make a choice between the two specifications? So we will try during the presentation to introduce the differences, but also how you can combine those two specifications. And we will also have a demonstration of Microcks. I am the founder of Microcks, so we will see how it plays very well with the two specs. So that's it. Do not hesitate. I will be in the chat.
Okay, so thanks a lot. And yeah, let me start playing the recording and enjoy, folks.
Hi, everyone. Thank you very much for attending this session at AsyncAPI Conf. Today, I'm going to talk about one of my favorite topics, which is the usage of specifications and contracts to ease the delivery of complex systems. I love the theory behind specifications, but I love even more when they can be used in a pragmatic way to speed up things. In the event-driven space, there's all these questions about AsyncAPI and CloudEvents that are two recent specification initiatives. People asking if they are competing, if they'd better choose one or the other. And I'll try to explain in this session that I think that they're in fact complementary and can be used together. You'll see that it does not make things harder, and that the Microcks tooling, the open source project I'm working on, can help you bootstrapping your AsyncAPI plus CloudEvents projects. But first thing first, let me introduce myself. So my name is Laurent Broudoux, and I am wearing many hats. On daytime, I am wearing a red one, being a solution architect at Red Hat, working on cloud-native technologies. And at night, I am putting on my open source contributor suit, and that's why I'm here talking to you today. Daily, I help organizations moving to cloud-native architectures and practices, integrating these new paradigms with their legacy. I have a special focus on everything related to distributed systems, API and specifications, Kubernetes, enterprise integration patterns. These are my favorite topics. And all the time, I'm a happy dad of 5 and a gardener. This has its importance for the end of the talk. So today, Events are everywhere, and they are the foundations of event-driven architecture. And we know that their benefits are huge. To sum up, it's all about decoupling. It's a question of temporal decoupling, allowing processing of events in real time or a long time after their creation. It's about technical decoupling, allowing different technologies to be used to be integrated together. And it's about runtime decoupling, adding resiliency and retry in case of failures, allowing non-blocking exchanges, enhancing the scalability of the system. But we know now that the rise of event-driven architecture often comes with many challenges if this type of architecture, it's all brand new for you. The first one is about the technology choice. This is a very broad and very hard topic. It's impossible to address in 45 minutes. We are not that ambitious. But I think it's important to take some assumptions on this one, as it may have consequences on the two others. In fact, I truly believe that it's impossible to pick up a single technology. Technology choice will always make you consider different use cases, as the event-driven landscape is very broad. So you'll probably end up with a solution for modern event streaming and analytics use cases, something like Kafka, Pulsar, or NAT. A solution for safely and easily exposing data streams to the outer world, like WebSockets or Socket.io, and some other solutions like AMQP, GMS, MQTT, for example, if you consider integrating with the legacy, or if you deal with IoT use cases, for example. So there is no silver bullet yet. And the reality is that you'll have to use different technologies to address this diversity. So we can mark this first challenge as solved, but it brings a lot of constraints that are inputs for looking at how to describe our events and ensure we share a common understanding on what's going on. There are also inputs for a third item on how to work efficiently as a team. This is because we probably don't want to have drastically different ways of working depending on the technology only. Again, this last one is very ambitious, and I only give you insights on how to quickly bootstrap autonomous development teams by breaking dependencies. So let's dive into the specifications landscape to check how to describe events. Things are perfectly clear on the way to go for request-reply-based communications using REST APIs. OpenAPI specification is the winner. But on the event-driven side of things aren't that clear. We have AsyncAPI on one hand and CloudEvents on the other. There are still emerging initiatives and people asking, are they competing? Are they tackling the same problems? Do you have to choose and then give up some benefits from the other spec? The fact that both of them are so-called specifications doesn't make it clearer, even if they are different beasts. So we'll try to answer those questions in a few minutes, and for that we'll have to dig into what they are and what pain they address. I suppose that most of you today already know AsyncAPI, so I'll try to be concise, but it's interesting to get back to the sources of each initiative to really understand that in fact they tackle different issues. So let's start with AsyncAPI. What is AsyncAPI? Obviously, you know that it is an open source initiative. It has joined the Linux Foundation, and its goal is to improve the design and the specification process of event-driven architecture by defining contracts. It is made to describe event-driven APIs that may be using different messaging protocols. In fact, it has an abstract part that is generic, whatever the protocol, and it may include specific protocols bindings information, such as destination names, quality of service levels, and so on. It can be seen as a sister specification to OpenAPI. It's very similar, And it may also use JSON schema under hood to specify the abstract part that is related to data. The very nice thing about AsyncAPI is that it allows definition examples. That is one of the parts we can heavily rely on to address our third challenge. If we have a look at the pain it tried to solve, it's really the one of users and consumers of event-based systems. Let's say you have an application, a system, some devices, whatever, on the left that present eventing capabilities. It may emit or process asynchronous messages. As a user, and without AsyncAPI, you always struggle to find information about those capabilities. What are the endpoints and protocols? What are the security policies? What is the expected data format? How can I validate my message? And so on. And AsyncAPI is here to answer that. Its goal is to allow an easy discovery and comprehensive understanding of the eventing capabilities of a system. For that, it implies the same principle as for REST APIs, so that event endpoints become truly managed APIs. In the AsyncAPI ecosystem, we find a complementary protocol binding specification, because AsyncAPI does not enforce any particular protocol, but the contract you write may embed specific protocol stuffs. AsyncAPI by itself is not a software library to install, but there is an extended tooling provided by the team and the community. So that there's this, for example, super nice online studio for editing. There is different code generators for different languages and frameworks. There is documentation generators as well as tooling for mocking, simulation, and testing. If we look at the anatomy of a AsyncAPI contract, we'll find some elements that really look like those from the OpenAPI specification. We first have an info header containing identification information like name, version description, as well as owner's contact, for example. Then we can find a servers block where you'll get the list of brokers that are offering access to the event-driven API. It may contain also different environments, protocols, and security informations. The most important part of AsyncAPI spec comes from the channel items definitions. Similar to the paths in OpenAPIs, channels allow us to define endpoints and operation on these endpoints. Operations are of kind publish or subscribe, and are holding message definitions where a message is clearly defined using headers and payload data schemas informations. At this point, you can choose to embed your own schema or to reuse existing ones that have been defined using JSON schema or Avro schemas, for example. The spec also allows you to define components like schemas, traits, message definitions that you may reuse across different channels or operations. Okay, so now we have a broad understanding of AsyncAPI. Let's look at CloudEvents. What is CloudEvents? According to the CloudEvents.io website, it's also a specification for describing event data in a common way. And from that, we can immediately deduce that the scope of CloudEvents is more narrow than the one of AsyncAPI. CloudEvents' focus is to provide common formats to guarantee interoperability across systems and platforms. In fact, it defines a minimal set of events metadata and serialization rules for that. CloudEvents specification is organized through the Cloud Native Computing Foundation Serverless Working Group, as the initial work around CloudEvents was triggered by the need to deliver invocation events to serverless and function as a service frameworks. So they try to put a standard for that in order to ensure the portability of functions and workloads. If we look at the pain it tries to solve, we can see that CloudEvents tackles very different problems from AsyncAPI. Let's say you still have an application, a system, some devices that are emitting events. We suppose that at the end of the day, this event should result in some new analytics or new data recorded into a database or data lakes at the right. And for this, you have to trigger some processing in the forms of traditional application, microservices, or even serverless or function workloads. And in the complex world we're living, this is very probably involving many kinds of middleware components. These components realize filtering, routing, aggregating, transforming, or brokering of events to their destinations. So this is exactly the problem CloudEvents try to solve. How to ensure that these middleware components are able to route and to deliver events in a very efficient way. This is more and more important as we are all adopting edge or hybrid cloud strategies. If we look at the ecosystems of use case in CloudEvents, we can see that as it addresses very common needs, the number of use cases is really large. So we can find CloudEvents solutions that are simply general purpose event brokers. That is what is providing the majority of cloud providers. But CloudEvents is also very well suited for event-based workflow automation. The use of the standard by the orchestration engine guarantees its interoperability. We also obviously find a lot of serverless or function as a service frameworks. The most famous being Knative, that brings a lot of components to implement Kubernetes native middlewares able to filter, broker, or transform events. And finally, we can also find a lot of specialized or vertical solutions that have been made CloudEvents friendly, so that the events they are producing can be later reused in any CloudEvents compatible pipeline. This is true for IT-focused solutions like Debezium or Falco, that is addressing security, for example. But it is also true for business-oriented solutions like commerce tools, for example. If we now have a look at the anatomy of the specification, you will see that it comes in different independent parts. The core specification of CloudEvents is a very tiny one, as it just defines the minimal set of metadata that every event should have. Nothing really new or exotic in here. It's just 4 mandatory attributes and 4 optional ones. So you've got attributes for defining the kind of events. It's the spec version and the type attributes. You've got attributes to clearly identify the event. This is the ID attribute. You've got attributes to define the context the event was sent out. It's the source or the subject and the time attributes. And you finally have attributes to define the shape of the carried event data. That's the content type and the schema attributes. The core specification also defines different locations or modes for transporting these attributes. The binary mode is adapted to existing messages, as it recommends putting the metadata attributes outside of the payload within the protocol headers. The structure mode defines a wrapped message format where the metadata are into the payload, wrapping the carried data. It's indeed very useful if you do not have a pre-existing message format. In my opinion, the names of the content modes are particularly ambiguous, as you can carry out binary encoded data using the structure mode, and you can also carry out text encoding data using the binary mode. I think that raw and enveloped would have been better terms, but that's how it is. Aside from the metadata definitions, there's also specifications for defining serialization details regarding the event format, JSON or Avro for the moment, and the transport protocol. Nothing more to say here, but let's look at an example. It will help to visualize things. So this is an example of a JSON encoded structured cloud event that uses the HTTP protocol. Imagine you have polled a GET endpoint and you received that HTTP response. The first thing to notice in structure mode, you see that CloudEvents has its own content type. It's application/CloudEvents plus JSON. Then you see that the metadata are at the root of the payload, and then you find the carried data with a data property. This property could be of any type, and this content type can be specified within the data content type attribute. Here in the example, you can see that we are transporting XML data, in fact. Now we can have a look at the binary content mode, and you can see that the metadata of cloud events are now serialized as HTTP headers using the C- notation. The data is the one of the payload, and the response content type is simply the one of the data. You can find the content type header having the text/XML value. The binary content mode is clearly my preferred way of doing things, as it allows to add cloud events capabilities to existing events, but also because I think it leads to more performant implementation of the middlewares involved in routing. With the binary mode, the middleware just have to consider the headers, and they can totally ignore the payload while they're doing their job. Okay, so we had a walkthrough of both specifications. Now let's summarize things. Obviously, AsyncAPI and CloudEvents are sharing common features. We saw that they are both protocol agnostic. They are also very friendly to different encoding. JSON and Avro and their schemas are supported. And there is also ongoing efforts in the community to make this list larger with, for example, the addition of protobuf to the list. Hence, we can conclude that both specification is able to support most of the technology choices and is also able to integrate with legacy systems. This is of great importance, as we outlined it when dealing with the first IDEA challenge about the technology choice. Now let's see the differences. Now in this table, I summarize how I see their differences, and then come to the conclusion that there is no overlap between the two specifications. Both are certainly very useful when dealing with large systems. They have different goals: to provide a description of API capabilities on one side, to ease interoperability on the other. And for that, they are focusing on different parts. AsyncAPI helps you define channels to be used for applications and lets you choose your message format. CloudEvents provides you useful common metadata to define the event's message format. You can also see that the people who are describing or using both specifications are also pretty different, and you certainly need to address all of their concerns. In an organization, the adoption drivers behind AsyncAPI are mostly the API owners, because they want to ease the discovery and the understanding of the API to ensure its reuse and success. Thus, the application developers are the consumers of the AsyncAPI document describing the API. And that is because the AsyncAPI document is mostly used at design time and build time. Choosing to use AsyncAPI or not, in fact, it has no real impact on what will be transported on the wire. And on the other hand, people most concerned about using CloudEvents are the platform architects, as it will allow them it will allow their product to easily integrate with the ecosystems, even for the use cases that they haven't thought about yet. The middleware developers will then be interested in the metadata values to deliver efficient middleware components. So you see, different concerns, different people, but all of them must be addressed. And luckily we are able to combine the two specs to get all their benefits. So let's see now how to combine them together. The combination of both can be achieved thanks to AsyncAPI extension mechanisms. Though, depending on the content mode you choose for your CloudEvents, you will have to choose different mechanisms. On the left side, we describe how CloudEvents fits in the AsyncAPI contracts of your event structure, event-driven API using the structure mode. Because AsyncAPI is leveraging JSON schema and its extension capabilities, you'll just have to reference the CloudEvents core specification and then locally describe the data attributes only. On the right hand, on the right side, we now describe the binary content mode. Maybe you remember that in binary mode, the metadata is serialized as message headers. So here, where we are using the trait extension mechanisms, that allows us to simply include the protocol headers in the AsyncAPI spec. You'll keep the raw payload definition within your AsyncAPI document. The nice thing about these two ways of doing things is that we don't bother about CloudEvents definition. It's just a matter of adding a reference to the spec and then focusing on the carried data definition. As it's still a bit theoretical for the moment, let me show you some code. And as said in my introduction, I'm also a gardener, and this is the back of my garden, and I'll use it to introduce today's use case. As I spend a lot of time at home lately, I wanted to set up an inhabitant sensor system. And I wanted a smart one, able to recognize different kinds of animals, cats, hedgehogs, squirrels, and emit events when entering or exiting the frame of the camera. So let's suppose we have this raw data represented here in JSON, containing the type of animal, a detection score, its pet's name, and the detection timestamp. The first thing would be to CloudEventify it. So we define a type to make the difference between entering or exiting the frame. This is the bullet one. And you can see that we also have a lot of context information. CloudEvent does not help defining the data, so we have to define our JSON schema outside and provide it into the data schema property. And finally, you can see in the data attribute the carried out business data of our events. It helps interoperability, but does not help describing in a formal way my architecture. So now let's see how we can use AsyncAPI to specify a contract without CloudEvents for the moment. This is an extract of my AsyncAPI definition for my animal sensor. And you first see the different channels definitions here. And as we have no mean in business data to make the difference between in and out events, we define two different channels that may result on Kafka topics, for example. As AsyncAPI leverages the JSON schema, it's now possible also to define and embed the description of the carried data in a formal way. We have the animal message payload description. So we now have a formal description of the data format, allowing the developer to learn the different channels and to understand the data structure. But it lacks context. And that's why we'd like to add a CloudEvents to the mix. First, we've structured a content mode. Okay, so we now have to change her AsyncAPI file, and you can see on the first bullet that we just have to add a reference to the CloudEvents spec here in the message payload. We can refine different types of events, okay, and we can locally define now the carried out data schema. So within the animal data type, we'll find the same properties definition as before. Let's now see binary content mode, and to spice up things, we can use an Avro binary encoding on the data this time. So the first thing will be to define an Avro schema describing a new animal record type. This has to be saved into a specific Avro schema file. So this is my Avro record definition. And now looking at the AsyncAPI document, you'll see that we have changed the content type of the message to binary Avro, and we are referring to an Avro schema. We have added a reference to a CloudEvent trait to include all CloudEvent specific headers. And finally, define our payload using the previously defined Avro schema. One important thing to notice here, don't be confused with the Microcks reference when specifying the trait. This is not specific to the Microcks tooling, this is just the name of the repo where the trait is stored. I hope that this example allows you to reconnect dots and make things clearer. You'll see them in action in tooling in a few minutes. So far, we've dealt with 2 of 3 challenges, and we saw that both AsyncAPI and CloudEvents should be considered in the picture when describing events, alongside with JSON schema and Avro, of course. Let's now see the third challenge, how to efficiently work as a team with events. And as stated before, this is a very broad topic, and I just explained how to set up an efficient bootstrap for your project. An important thing in starting every project is the feedback loop, how to ensure that that what we design is of value for the people who are using it. In the context of an event-driven system, there's the additional difficulty of having access to the infrastructure. It's better to not have to wait for the sensor to be plugged and to detect animals in the garden to start developments of processing and giving feedback. So that's the problem we are going to address now. And specifically to address it, we are going to use one very nice feature of AsyncAPI and contract design in general. It's the ability to specify examples. Often we neglect the importance of examples. Most of the time we let some tools generate them, and finally all the string properties have a value of string, all the number of properties may have a value of 1, and so on. But I do think that it's a best practice to pay a great attention to the examples, because they should represent real-life scenario. And when carefully chosen, examples can be real good illustration of business expectations, and thus they can be later used as executable specifications. So basically, that's what we are doing with the Microcks tooling. We turn the examples from AsyncAPI into actionable simulations to realize mocking. And then later we are able to reuse them as datasets to realize testing. Let me say just one word on Microcks. Microcks is a project I started some years ago, and it reached the 1.4 release last month. It's an open source Kubernetes native tooling. It provides a tooling for API mocking and testing. We are tackling 3 specific concerns when dealing with API with Microcks. The number one is to shorten the feedback loop, because API are products. People are adopting agile methodologies, so they want to get feedback very early in the process, and they want to be able to rapidly evaluate new changes. So this is the main driver. The number 2 is how to parallelize developments, because once we decide what is the API to develop, we absolutely want to avoid any bottleneck. We do not want to have developers consuming APIs to wait for backend. In our case, wait to have the animal sensor plugged in the garden. Number 3, it's how to validate implementation. This point is getting richer when you are releasing numerous versions of your API, and you will need to be sure that your implementation is still backward compatible. So Microcks is able to realize contract testing with each and every changes. The big differentiator in Microcks is that it's doing this for all kind of APIs. Event-driven APIs, of course, but also REST APIs, legacy SOAP web services, or gRPC services. So in a nutshell, Microcks proposed 2 different use cases. The first one is about simulation or mocking. It integrates with your source of truth, your Git repository. It discovers and generates live endpoint in seconds, so the API consumers can start playing with the API as it was live, as it was already developed, without writing a single line of code. Okay. The second one is about ensuring compliance. So once your team has started, you can plug in Microcks within your favorite CI/CD pipeline runner, and within each and every commit, you check if changes break compliance on your API version contract. Okay, so let's finish our talk with a rapid demonstration of Microcks on our garden sensor use case. First things we can see here is our AsyncAPI definition that has been loaded into the AsyncAPI Studio Online, and we'll find here our animal sensor structure API. This is the structure version of this API. And one thing we have started with is to add examples to this API. So here I have defined 2 examples right here, and I have just defined them using YAML structure. Okay. In the payload of these examples, I will have the different CloudEvents metadata informations right here, and the wrapped business data of my message. Okay. Within examples, I surely want to put some static informations, like for example, the type, the kind of event that it is dealing with. But in order to be effectively used, I can also use some specific notations right here, using a double mustache notation to specify, for example, that here I would like to have a unique identifier, and here using the now function I would like to have a specific timestamp. Okay. This specific notation is indeed understood by Microcks, so that later on we will be able to produce some dynamic values within the example. And this is very nice for the different consumers that will play with this example, so that they have a dynamic data and, with a rich data sets. Okay, so let's now imagine I'm happy with this design, and I can save everything into my source of truth, into my Git repository. The next step is now to import everything into the Microcks tooling. Here I have the Microcks tooling running. Okay, it can act as a central repository for all your API and services definitions, but the repository is empty for the moment. Okay, so you can manually add new definitions by uploading contracts and specifications, but you can also import them from your source of truth, from your Git repository, using an importer. Importer will allow you to define a scheduled import or to define webhooks, so that with each and every design revision, Microcks will be updated with the latest changes. So let's start with the structure version of this API, and we will activate it into Microcks. So it will normally discover this API and yes, populate the repository. Right here we find the animal sensor structure API. Okay, we have access to the AsyncAPI contract and documentation. Okay, and we can see the detail of operation, the subscription when you've got animal detections. And just right here, you'll see that Microcks has found 2 samples, 2 mocks that were defined within our specifications. Microcks is able to manage different protocol bindings for your AsyncAPI, Kafka, MQTT, or WebSocket. Kafka is currently the default one, so just after having imported the API definitions, Microcks has created for us a new Kafka topic for this API, and each and every 3 seconds it will publish new messages on this topic. So as an API consumer, I can just start playing with the topic that is managed by Microcks, and each and every 3 seconds, if I use the animal sensor structure API topic, I will retrieve new events that are dynamically produced by Microcks. So we have not yet written a single line of code. Just from the specifications, Microcks allows you to bootstrap your feedback loop. Okay, and we can check that each event right here has a unique identifier and a generated timestamp for each and every message. Okay, so very nice. Let's now check the binary version of this API and the particularity of the binary version. So in the binary version, I want to use Avro binary encoding. So I have had a reference to an Avro schema within my AsyncAPI file, as demonstrated before during the presentation. But when you use Avro in a Kafka ecosystem, you want the Avro schemas to be published and accessed through a schema registry. The schema registry will allow your API consumer to dynamically retrieve the Avro contract so that they are able to deserialize the data carried out by the event. So connected to Microcks, I have a schema registry. I'm using the Picario registry that is for the moment empty. And we are going to activate this API in Microcks. So, like previously, it has detected this API, the binary version. You can see that it has also found the Avro schema right here, and you have details on the operation as well. So this time, the different CloudEvents metadata is mapped, is projected onto the different headers. Okay, and you'll have the Avro data of the sample that is represented as JSON right here. It's better to display JSON here because it can be read by humans. Like before, Microcks has created a topic for us, okay, but also it has dynamically published the Avro schema on the registry. So now, as an API consumer that is dealing with Avro, I can directly reuse the topic that has been generated for me by Microcks. So this is the binary topic I will use, but this time I specify that the value is Avro, binary Avro, and I will have to use the registry to dynamically retrieve the schema. And you can see this time that, yes, that's it. Each and every 3 seconds I still receive new events. I have all the CloudEvents related metadata that are provided within the headers by Microcks, and the Avro that is put here and deserialized and displayed as JSON for ease of read. So you can see that by setting up Microcks, you can very efficiently set up a feedback loop and bootstrap your development team so that I can start developing in parallels, even without writing a single line of code. Let's get back now to the presentation. Okay, so let's wrap up things. We addressed the 3 EDA challenges we previously identified, adding a mix of examples and Microcks tooling to the previous one to ensure quick bootstrap of your project. Of course, it required a lot more to guarantee efficiency during the whole project life. Finally, if you would need to recall just one thing, these are the key takeaways of my talk today. I hope having succeeded in demonstrating that it's not a matter of AsyncAPI or CloudEvents exclusive choice. Both are very useful to design and implement your event-driven architecture. AsyncAPI defines the whole EDR space, and CloudEvents ensures interoperability. Both are very useful to address the concerns of the different people in the organizations, API owners, API consumers, platform architects, or middleware experts. And luckily, they can be combined easily, and they can also be simulated very easily thanks to Microcks. This ensures the setup of the feedback loop in your project, and this ensures also the setup of the conformance validation. Okay, because the examples you have put in your specification with the schemas information may be reused later by Microcks to ensure that the real data that is produced by your application is in conformity with this contract. Final word on Microcks. We are an open source project. We welcome everyone to come, to share ideas, to contribute. We want it to be purely community and user driven, so try it, give us feedback. Do not hesitate connecting and chatting with us on our Zulip chat. Many thanks for your time attending this session today, and see you later. Bye-bye. No. Don't know if you can hear me, Fran, but I can't hear you.
All right. You should hear me now, right?
Ah, yeah. That's correct. Yes.
I didn't turn on my mic, as always.
Classic stuff.
Classic stuff, exactly. I never think that I have to turn on a mic. That is always turned on. Great presentation, Laurent. Really enjoyed a lot, and really cool stuff with Microcks. So yeah, congratulations for that. It's a really cool project. We're gonna wait a few seconds more for questions, for the delay. We have some delay between the platforms, so yeah. But I think they're already there. You got a question from Tamimi during the talk, but I can't find it now. This is mainly for those who are watching the recording afterwards. They don't have the chat available.
Yeah.
So yeah, I'm gonna just post it here. Maybe you want to, I don't know, add something, or maybe not. That's okay.
Yes. So I still think that the main adoption drivers for CloudEvents are still the architects, the platform architects, because they really think about interoperability, about developing efficient middleware components. So, in my opinion, they still are the main drivers. But I do think that CloudEvents will also serve the needs, serve the concerns of the API owner, because at the end, it should help also to ensure the reusability of the API. So even if CloudEvents are more technical stuffs that AsyncAPI, at the end, they should also be prescribed by API owners when they know actually that CloudEvents exist.
All right. It is funny that you mentioned that that distinction between AsyncAPI and CloudEvents, like AsyncAPI is more for API owners, and AsyncAPI is more for API owners, and CloudEvents more for architects and people worried about interoperability and all this stuff. Because when I created the Async API, my main concern was interoperability. so it is like something is not working. Maybe.
No. I think you succeed, but I think CloudEvents is really about interoperability at scale, at multi-cloud and at hybrid cloud scale. So. Yes, AsyncAPI does the job for interoperability between consumers and producers. But when you're at scale, when you go outside from the organization boundaries, there is this need of a minimal subset of common metadata, and this is CloudEvents is for.
Yeah, I agree. Yeah, and I agree with that. Like, please use both. It is much better than just using AsyncAPI or only CloudEvents. So yeah, I agree with you on that. Cool, folks. So we're gonna do a break now, and after the break, you'll stay here. Okay. So we're gonna do the panel on the future of AsyncAPI. Let's see what we have to say, and yeah. So see you folks in a few minutes. Take some time for the break. Bye.
Bye.
All right, folks, we're back. So next up is the panel, the feature of AsyncAPI. And today I would love to invite so that we introduce them properly, right? I guess you heard about this guy who's coming now, Laurent.
So, should I do it again? One more introduction?
Yeah, let's do it again, just in case for those
Yes.
watching the recording and or that just joined now, or
Perfect. So, hi everyone, very happy to be here. My name is Laurent Broudoux, and I am the founder of the Microcks.io open source project that is using AsyncAPI to easily simulate and realize contract testing on asynchronous API. And during the daytime, I am also working as a cloud native expert at Red Hat.
Awesome. It's a Red Hatter.
Yeah.
Yeah. Next one, Jonas. Get ready for that. Get ready for prime time. Are you ready now? Okay. Okay. Let me change the layout here. It's gonna be a little bit difficult to arrange this layout today. And so Jonas, you mind to introduce yourself?
Yeah, sure. So my name is Jonas, and I am a senior software engineer at Postman, working with Fran in the Open Technologies department, where we work on AsyncAPI full time.
Awesome. And also an early contributor of AsyncAPI. You missed that part, but you have been there for years already.
Yes, it actually just rounded 2 years, I think.
Yeah. Amazing. How time flies. Next one, a Canadian that made me a cool game of guessing who's the singer.
Weirdly enough, I am not a Canadian. I am American, but I love Canada. So I wanted, and plus I wanted to put you through that. So my name is Jesse Manning. I work for Solace in the CTO's office, and it's a pleasure to be here. Thank you.
So I'm disappointed. I thought you were Canadian. So can we just kick?
We
out
can't
this
all be
guy?
perfect, man.
Okay, welcome, man. And last but not least, the next guy, also from France, Ludovic. You probably heard about him as well. So
Hello.
welcome, Ludovic.
Yeah, my name is Ludovic. I am a solution architect. I work in INEAT, a French digital company. And thanks for the invitation, Fran. It's a real pleasure.
Thank you for being here. So these folks here today have no idea what they joined to. I didn't want to explain because I had no idea as well. So I just wanted them to be on stage, right, and share some time. And so I'm not alone here. But no, I'm kidding. Like, I wanted to invite you all to speak about the future of AsyncAPI, or also, I mean, we can also mention the past and the present, of course. It's not forbidden. But I wanted this to be like a casual conversation, but no casual conversation ever starts without someone speaking and saying something, right? Otherwise, we'll all be here like, okay, whatever you want. Who's next? Who starts, right? So, so I'm gonna just throw a question, and you tell me what you think, all of you. Okay, so you can start in whatever order you prefer. So, folks, what do you think? I guess you are aware of the roadmap of the AsyncAPI roadmap and the goals that we have and the vision that we have. What do you think about this vision and roadmap? Just to make it easier for people to follow. Like, the vision is that we become the number one specification in about 5 years, 4 or 5 years, right? For any kind of APIs, right? And yeah, just that. What do you think?
Okay,
Maybe,
the
okay.
American will talk first because that's like my role here. I am skeptical. I would love to see that come to fruition. I think the challenge that I have with that vision, I think AsyncAPI is fantastic, and obviously Solace is a huge supporter of AsyncAPI. But to become sort of the even by reference to other schemas like OpenAPI and GraphQL, it seems like, if you envision a pyramid, like, where AsyncAPI, OpenAPI, GraphQL are sort of on the same level, and it feels like we need the logical next layer up schema to sort of encapsulate, these cross-cutting concerns that I think that we all acknowledge, like, and I'm really actually intrigued by the serverless workflow talk that's coming up. So I feel like, well, maybe that's sort of a thing that, because they link to so many different schemas and can kind of capture the relationship between them. To me, worthwhile goal, but maybe not what we should be focusing on for AsyncAPI.
Yeah. I share some of Jesse's thoughts because the nice thing about AsyncAPI is that it is built on a common grounds with open APIs and some other specifications. But maybe don't know to be shy, but seeing AsyncAPI as the number one for every kind of API is very, very, very ambitious. And I think there is a place for some other kind of wrapper that can use the different specification, the different existing specifications, and that use these common grounds of JSON schema, of Avro schema, of protobuf schema, to mix these different kinds of API, REST APIs, GraphQL APIs, and AsyncAPI. So I would not say it's you have to choose one and this is the one that will win and lead all the others, but there is a place to build some kind of wrapper to use and to play with, to have the best of both worlds.
Yeah, I share I share that this is an ambitious roadmap. I think we can improve a lot the tooling around AsyncAPI to have the same achievement as the tooling of OpenAPI. So the code generation and all the ecosystem around AsyncAPI, but from my side, this is we do a work to provide this kind of work, and so this is good. This is good. And, it's nice work.
And I should say that I'm sorry, Jonas. Do you want to? No.
Go ahead. Go ahead.
I think that I think it only emphasizes sort of I mean, I want to acknowledge that Fran's not saying let's go over and grab what OpenAPI is doing. I respect using things by reference. And I think that's a point well made. I think we disagree where that lies, sort of in the logical layer of things, but I don't think that in any way diminishes sort of the task in front of AsyncAPI and the importance of it. Simply because we've celebrated all conference long, like it's clearly exploding. There's clearly a lot more to do, and so rather than I think my focus would be on let's be the best absolute representation of asynchronous interactions, rather than sort of moving on to sort of a higher level concerns. So maybe that's a more positive way to talk about it, because I think that we have so much to offer and so much to do, and that would be my preferred focus.
So Jonas, you want to?
Yeah, maybe. So
remember, you work
might-
for me. You're reporting to me.
That's true. I gotta be careful. But yeah, my take on it is that like we're coming into this trying to change the entire perspective on tooling, right? Because we are used to OpenAPI having community-driven tooling, JSON schema having community-driven tooling. In terms of there isn't a term called official tooling.
Yeah.
There's only what the community separately work on and provide, where we try to bundle everything together and provide the entire ecosystem, right? And it cannot happen without collaboration. And when we come into this by changing this entire approach, we're also starting to come short and in terms of tooling that we have to all of a sudden create just to create tooling around AsyncAPI and to provide interoperability between the specifications. And that is a huge effort that needs to be done.
Yeah.
So just to add what Jonas said here, thanks for repeating aloud what I share with you privately, Jonas. I'll send a check afterwards. just kidding. We're always trolling each other. So no, really, like I appreciate the transparency here. That I was already like aware that is an ambitious goal. The vision is a really ambitious goal, but you have to set ambitious goals if you want to go in a specific direction, right? We might not reach that goal ever, but by looking at that goal, we might go in the right direction, and we push harder in that right direction. This is like when you have this feeling that you have an exam in 2 months, and you're like, it's still 2 months, right? So let's just relax, and then 1 month, 1 month, that's fine. Then time goes by, right? And then in about I don't know, like 3 days, it's 3 days, and depends on the exam, you might still say that 3 days I can still study, right? But as it goes closer, then you realize that, oh damn it, I should have started earlier, right? Pushing in this direction, like start to study, right? To pass the exam, right? So I have the same feeling, like we can, before we reach that vision, we have lots of things to solve in EDA, right? In event-driven architectures. And that's why you're not seeing any efforts yet on GraphQL support or OpenAPI support or gRPC, or that's why we're not even touching that, unless someone is doing something on their spare time. That's fine. But at least myself, I'm not telling anyone that, hey, let's focus here because we should go right now in this direction, right? I think it's too early, like super early for that. I wish that we reach that point at some point, reach that stage at some point. But just want to clarify that, in my opinion, doesn't have to be that AsyncAPI specification needs to adapt necessarily. So probably the solution is that we create another specification or superset or something like that, like a wrapper that will understand all the other specifications, and we'll collaborate on there, right, on this other specification. That will mean, though, that we have to create new tooling, right? And that is like that's the downside, right? Like we already have tooling for AsyncAPI, so yeah, we're close. I mean, we can reuse for sure. But
well, I mean, what do you think about serverless workflow? Do you think that could fit the bill, or is it truly, or for that Postman collections for that matter?
I have no idea, to be honest. Like, I have no idea about serverless workflow. I need to learn more about it. We have a talk, luckily.
I know.
So it's gonna be cool that we have someone to show us about the serverless workflow. But I have literally no idea. I have the basics, So no opinion in there. What do you think?
It's interesting because Laurent. You just oh man, that's
Laurent in French, Laurent in English, as you want.
Well, I mean, you just started working with collections.
Yeah.
Microcks supports it. What's been your experience with that? Could that serve the role that we're sort of talking about right now?
Yes, that's true. Microcks supports Postman collections, but actually, I would say that this is pretty difficult to handle for the moment because at least for the version 2.0, 2.1 of the collection format, it is not very formally typed schema or specification. So you have to, I personally have to dive a lot to understand how it works internally. So for me, as it is, Postman Collection V2 is pretty hard to understand and to build something else upon.
Fran, is your boss listening right now?
Sorry?
Fran's boss is like the owner of Postman Collection. So I'm
I'm not the owner. No. Literally, I was laughing because people in the chat are just trolling.
Not only trolling Fran, of course.
Of course. I have no literally about collections. I'm getting up to speed with them.
Yeah.
I should be getting up to speed right now that I'm working at Postman, but yeah, at least what are the how can I say, the intricacies of the spec itself, like the collection spec. Literally, I haven't been part of them, and I haven't touched anything. I've used collections, I guess, like everyone else here on Postman, but as my daily work tool, but nothing else. No quotes on t-shirts. I have Alejandra saying that actually no, it's Tamimi suggesting that we should put this quote in a t-shirt. So Tamimi, a good troller. So what was I going to say? I can't. Yeah, I forgot. So following with this, Laurent today wrote a message on one of the proposals that I've been creating for solving the publish and subscribe confusion, and he made a comment. Actually, you can read your comment out loud. We don't have to. Maybe
yes,
you can comment it.
I was reviewing the proposal for the version 3, the AsyncAPI, and while going down the thread, I see many not say problems, but I ask many questions. And one thing that strikes me, it's about the duality between do we have to represent the application interface with AsyncAPI, or do we have to represent the whole application ecosystems? And I would say the application implementation as well. And so, for example, when you talk about the servers, the server part into the specification, there is this discussion about do we have to qualify them using local, using remote, and these are very different concerns. So, for example, local servers, the API consumers doesn't care about local servers. This is just a concern for the API developers, the people that will actually implement the API. So I was thinking out loud about what is the real scope of AsyncAPI. Should it stick with the interface representation, or should it go larger, embracing the application representation scope also? And I was just thinking about what about just putting AsyncAPI on the interface representation and starting a new spec that could be open app spec, open application spec. That could be a wrapper, could be a combination of open API for the synchronous interaction of an application, AsyncAPI for all the asynchronous capabilities of an application, and just trying to solve this problem of application representation, not in the AsyncAPI, but in a broader project that would allows us to benefit from both REST APIs, Open APIs, GraphQL APIs, and then AsyncAPI on the other hand. So this is my afternoon thought. So just throwing it away. Let's see.
What do you guys think about it? Like another specification. I have the feeling that that maybe thinking about the scope that you just mentioned, it's not just that the scope is API or application. I will say that even right nowadays with version 2, the scope is already application, but it is kind of like intermingled with API. Jonas is saying like, yeah. Like he's the one suffering it, so he knows. So yeah, that's already there. But also like one of the other scope discussions, I would say, is should we be representing client server relationships or only broker-based relationships, or should they be split in different specs maybe? Should we abandon one of them? I don't think so, because both of them are huge. So yeah, like for instance, WebSockets. You have WebSockets, which is very widely used and still growing. This is mainly a land of client server, right? Like you have the browser connecting to a server and exchanging messages, and that's it. There's no broker in the middle. And then you have, I don't know, Solace, Kafka, and other brokers, right? Which is a completely different pattern, and all the applications are clients. I mean, there's no server. The server is a broker, but there are no server application. All the applications are clients. So then, that's in my opinion where all the problematic comes there. Like you have to, adapt AsyncAPI to work well with defining clients and defining servers. And what do you think about it?
That was a long ass question, though. Sorry, my language.
It was actually a very, very short ass question, preceded by about 13 paragraphs of talking. The question itself was only like 3 words.
Did I say it was a short question?
I'll take a stab at it. I think that is truly sort of the question. I think well put by Laurent. Laurent? Sorry. So I do think that there is a very sharp dichotomy between this sort of peer-to-peer and broker setups. But I do think there's common ground, and I don't think that we should abandon either one of them. I think the key really is to create a really strong. Sorry, Lucas is making notes about who not to invite next time. That's probably me. So I do think the key there is, in all these situations, finding the commonality and keeping that be the logical layer. And then, we've got 2 things interacting with each other, or multiple things interacting with each other, applications, services, and they're connected by some sort of tunnel, whether that's a broker or a TCP/IP connection, and there's a data format there, and then everything else is sort of a logical is physical binding below that level. To me, saying, well, let's focus on application interfaces rather than infrastructure is really hard, because in some ways The comparison being, of course, to OpenAPI. OpenAPI gets to do that because there's this huge assumption about like the infrastructure. It's going to be REST. It's going to be over HTTP. Everybody has the same verbs. They get to make those really fun assumptions because they are less complicated than we are. We have to consider the infrastructure in some sort of way. The question is just sort of the best way to do that.
Yes, but luckily we've got bindings for all the things related to infrastructure.
Totally agree. But and I think the key there, I totally couldn't agree more, is like to keep the infrastructure related stuff out of the core objects, and like you said, defer them all to bindings. So that's why I get nervous when I get things like when things like replies get introduced into the sort of the core objects, because there's no true concept of a reply for a brokered architecture. So to me, and also sort of this, Fran and I have been talking about local and remote for ages, and that's why I'm nervous about that, because that seems to bring in some of the physical infrastructure into the more logical layer.
Yes. Yes, I think it's very important to dissociate the different parts of the spec, and that was a feeling, that was thinking I had this afternoon while reading the thread, is that because we have a holistic view of the specification, and most of the time we are coding demonstration and having the holistic view of the infrastructure, the data format, the message payload, and so on. We have some bias. That means that I personally addressed all these things together. But when I talk to people on the fields about AsyncAPI, the reality is that the AsyncAPI specification file is really built incrementally with many different iterations. And people usually start with the descriptions of the message format. That is one thing. Then all the things related to bindings come later on. And later on also, there are the things related to servers. And most of the time, I can see AsyncAPI files having no servers at all, because the development is done, it is in the staging and the QA pipe, and somehow it will land on the production servers, but nobody cares. So I think this is very important to make the dissociation of the different parts, because they are introduced into the document at very different phases in the project, and by very different actors also. Ludovic, maybe you have an opinion on this point with your experience at ADO. I don't know if you've seen the same things that me.
I don't participate yet in the thread, but we provide in ADO an AsyncAPI documentation for our users, and so the goal is to explain to our user how to deal with our exchange, and in this way the usage of publish and subscribe in our case is obvious. So how to communicate with our product thanks to a publish operation, and how to get responses from our product like subscribe operation. So we have an approach for the user and the user experience. And it's not tactical, or it's not about client or server, but focus on our user experience. And it's my opinion, and the way I use AsyncAPI to document our exchange. So, but the subject is not easy.
And I think that just this part brings huge benefits for the project and for the people who want to use this API. This is, for me, the most important part.
I have the feeling that maybe Laurent, so you're coming from the server perspective. So Microcks is the server, right? When you become the server at some point at least during mocking testing, you become the server. So that's why you're probably not interested in the server part, or the people working with Microcks are not interested in the servers part because Microcks can fulfill this information by, like, I am the server, so you point at me, you subscribe or publish to me. But those who are not using Microsoft or any other server side tools, like any, not server side, but any mocking or testing tool, then you might want to, like for instance, an example, client generation, like code generation for a client. You might want to know where exactly to connect, right? Like where exactly to connect to send the messages and to publish them, right? Like,
yes, but
or
actually,
I'm gonna challenge you, like, or I'm gonna challenge my point. Like, do we need to actually know this information from the spec point of view? It's for all of you, not just
yeah. In my opinion, knowing the server address, the port that is used is not really that important for client purpose, because most of the time this is something you want to put into external environment variables or configuration parameters. So this is not something that will stick into the code. So it's very important to know what kind of bindings you are facing. Is it a Kafka broker? Is it an AMQP, MQTT broker? Because it allows you to adapt and to generate the correct code skeleton. But you don't really care about what is the server and what is the port. These information are just really important and useful when you are dealing with public-facing APIs. If you want to describe your sandbox environment and your QA or production environment to partners. But I would say that internally, when you are within the boundary of the organization, I'd say it's not really very, very, very important. The kind of bindings is very important, but the real information about the servers and the ports, not that much. This is my opinion.
That's my experience too. You're passing around, Postman collections, or you're passing around, SOAP UI files. You tend to just type in the URL into the box and you press enter. So passing around the server information within the spec itself, like you said, is mainly focused on external and really, really static endpoints like api.postman.com or something like that.
What do you think then, for instance, about documentation? So you said, Laurent, like, for instance, this is mainly for external APIs, but if you're in a large organization and you want to consume other teams' messages, other team endpoints, you want to check documentation, right? But you might have different brokers, like depending, not just a single broker for the whole company. So for instance, one of the cases is that you have a broker per domain in domain-driven design. So you have like a broker per domain, and you need to know where to connect to consume this event, right? Like you want to read this information in the documentation, right? So isn't it like...
Yes, but
this is my use case. Yeah.
So sorry? You are referencing the address of the servers within the AsyncAPI file directly?
You asking me?
No, Ludovic. Sorry.
Yeah. We document the server URL and the schema registry bindings, for example, the way to authenticate into the broker with SSL or other protocol. But this is important to bring this visibility to our technical developers. Even if in an organization they know how to connect to the broker, but this is the minimum to do. in this spec for an optimum usage, an optimal usage.
I actually love, and I would love people to reflect on this conversation. Like, now it's a real conversation to realize how many use cases we're trying to cover here. Like, it is, there relies the complexity of AsyncAPI, right? It's not just client server or not client server. It's also like, what about from the point of view of the broker? What about from the point of view of the mocking of Microcks, right? What about from the point of view or of people wanting to consume documentation, not generate documentation, those who want to read it? What about from people who want to generate code, right? So there, in my opinion, relies the complexity of the whole thing. Like, everyone wants to be represented there.
Totally. Yeah, I think it goes even beyond that. I think those are all fantastic, but also, like, how are you going to store AsyncAPI? Is it all going to be flat files stored in GitHub, or is it going to be some sort of registry? And are you going to have your schemas be, I've been the schema registry talk, like, are you going to have the schemas represented within an AsyncAPI? Or are you going to link off and have another schema registry? Like, the topologies are pretty remarkable and intriguing, but challenging as well.
One thing I want to point out is, sorry.
Go ahead.
Like, the one thing that I find intriguing about AsyncAPI is that we try to define it from an application point of view. The problem is that we borrowed a lot from OpenAPI and the perspectives, and that is hurting our butt at the moment. With this suggestion that Fran made, or you all made, basically, really tries to solve going back to the application perspective. So you just have an application, whether that's a Kafka consumer or producer, or whether it's an HTTP client or a server, it's just an application in a sense. And that's one of the things that I find, what's it called? That I like about the suggestion, that we try to go back to that specific route about defining it for the application itself. This also means that when you try to define the interface that others interact with it, they need their own AsyncAPI document because you see that specific entity as a application on its own, right? So it needs its own document as well. And this is one of the things I find at least really interesting, that we try to change this entire perspective. But it also means it's going to be more difficult if you come from an OpenAPI background or GraphQL or whatever, is that we define applications, not servers or interfaces, or it's a difficult subject to discuss.
Yeah, well, I do agree. It's a good move, and I think Fran and I have a fundamental disagreement on this one as well. I do think that moving towards application sort of centric view is good, but probably not far enough. And I'll cite Laurent and Mitchell as introducing this concept of having explicit endpoints. To me, for multiple different reasons. One, the sort of different mechanisms for storage. The other being sort of the ability to expand upon and extend endpoint definitions. It seems like we need to, not only be able to explicitly define an application as being, sort of this is from the perspective of an application, but have an application be an object that we can in turn manipulate. If we continue to have the application be bounded by a file, that sort of constrains us both in terms of the how we present AsyncAPI files, and also the manipulation that we can do on an application. Like I said, you can't extend it. You can't sort of give people a range of options and then have them select it for their implementation. It feels like as we're moving more towards enterprise grade, I think it's enterprise grade already. Clearly, enterprises use it, but as we expand upon those enterprise grade features, that maybe we will regret not pushing it even further and introducing something like an endpoint option. Mm-hmm. So I don't know if I'd be interested to hear the practitioners' thoughts on that.
Totally. So Ludovic, any insights on that part?
Yeah. We actually have a discussion with my team about how to document our actual AsyncAPI exchange for from our partners, and how to document our internal exchanges for generation purposes or other. And this is not easy because we don't want to mix our internal documentation with our official documentation, and we want to find a way to not aggregate those documentation. But for now, we have no responses for this problematic. But we actually discuss about this subject. So I wait for the next version of the spec.
I actually want to ask the next question because it kind of follows this. If we define it from an application point of view, right? How far is it from trying to define how applications interact with each other? Because at the moment, right, if you have two applications that need to be correlated in some way, the only thing that we have in the specification is something called a correlation ID. There's absolutely no way to, and references, of course, but kind of not really a way to do that. So I just want to hear your thoughts on that.
Yeah, I think also if we clearly adopt an application perspective, there is a big, let's say, risk, but it's big issues about bringing on the table all the concerns related to governance. And this is very broad because people will definitely want to manage references, what application consumes what other applications publish to what other application. And this really can become a real mess if we try to mix that with all the concern related to the interface representation. So this is very hard to define where to stop, what is the boundary. But in my experience, I think it's very hard to imagine a single spec that could be able to handle all these different cases and these different concerns, especially regarding governance.
Yeah, I think the sort of the interrelationship of these applications, if we choose to define it that way, I think that gets real complicated real fast, especially in a brokered environment where things could be one to n, and then multiple paths down the road. And I think that's where I would see us kicking it down the road to something like serverless workflow, and having that be the mechanism by which we lay those things out. In terms of governance, absolutely. But I think that is something, it's a mess. But if you totally ignore governance, it's going to be even more of a mess. I think that's why people turn to AsyncAPI in the first place. And so, I think our job at AsyncAPI isn't to define like governance workflow or structure for people. I would say our job is to give people flexible enough implementation patterns so that they can implement the spec in the way that makes most sense for their governance and works for their enterprise. In other words, if you're organized by a domain and you govern by a domain, then you divide up your AsyncAPI specs by domain, and those people, they're in charge of the pull requests. I totally am sympathetic to Laurent and say that is a big mess to get into, but I think we should at least provide the hooks for people to implement their own.
Yes, but it's very difficult to, yes, sorry, as you said, we should provide a hook, but I think it's over ambitious to think we will provide the whole governance framework, because with all the governance concerns comes all the concerns about diversity in the organization, because I think API is still quite new and there is a lot of legacy. There are still SOAP web services using WSDL. You have to govern, so it's kind of very
There's
hard.
still COBOL out
very
there.
tough, yes. Yeah, still COBOL with IDL. And yeah, so I think it's over ambitious to mix these concerns with those with clean interface representation.
Awesome, folks. So that is a truly like a debate that I truly love, but we're running out of time. Sadly, we need to give people a little bit of time to rest before the next talk. I would love to thank you all for joining the panel today. I think we should do more of this more often. And before I finish, and before I ask you to say some last words, let me say sorry and ask for forgiveness to our community, because look at this panel and it's full of white dudes, and so diversity here is not at all represented. It is not present on the AsyncAPI community as well. And just want to say, for those who are watching this panel and are wondering about it and will watch the recording later, that we're working on this. We have actually we have women working on this, so we should not be working on this ourselves alone. That's something that should be led by women, and not just women, but like all the underrepresented collectives in tech, right? So from the bottom of my heart, sorry for this lack of diversity this year. We'll try better next year. And with that said, so you guys want to say some last words? It's not a question. You guys said the last word.
Well, I feel like I said a lot of words, but thank you for the opportunity, Fran. And I'm looking forward to more of this, like you said, as we move towards V3. I think there's a huge opportunity there, and I'm looking forward to being part of it.
Yeah. Thanks for the opportunity, Fran, and keep up the good work. Love this community, love the openness, the transparency. So,
yeah, thank you, Fran.
Thank you.
Thanks.
it was getting shorter and shorter until the end. Love it. Well, thanks you all for joining. And it's not just my stuff, so it's all a community effort. Actually, this whole conference is like I will say, at the very least 60% Lucas effort.
Yeah, shout out to Lucas. That's how we should close
out.
it.
Let's just bring Lucas in just for a second. Yeah, man. Yeah, you're getting in.
You can't do that to him on short notice, man. That's not fair.
He's just sitting up on his feet.
Lucas is in
his kids are just getting home from school. That's a dangerous time period.
You cannot see him, but he's on the backstage and he just ran out. Damn it. Okay. Well, so Lucas cannot be. Let's just do this for fun. So here's Lucas, right? Here's where Lucas will be there. But yeah, so thanks a lot, everyone, for joining, and let's keep chatting. Thank you.
Bye.
See you next year.
Bye, friends.
Bye.
Hello, hello. Welcome back. Let's continue with our next talk, and let me invite the guests. The speakers, not the guests, actually. They're so Charles Davernas. Am I pronouncing it correctly?
Yeah, perfectly. Hello.
Welcome, man.
Thank you very much. Thanks for having us.
No problem. And Tihomir Surdilovic.
Yeah, nice. Yeah.
Is it correctly?
Yeah, you got it.
It is one of the cool things about running a international conference is this challenge with the names. You know, everywhere, like we are all used to our like a very limited set of names that we're used to, right, in our environment, and then suddenly a new name appears and it's like, oh, how do I pronounce that? Right? That feeling, right? And you don't want to do it bad because it's the name of the person, right? So, folks, you want to introduce yourself, maybe?
Go ahead, Charles.
All right. So I'm Charles Davernas. I am a co-founder of Neuroglia SRL, which is a Belgian tech company focusing on cloud-native technology, event-driven architectures, and all other technical stuffs. And I've been working, I discovered actually, thanks to Tihomir right here, because we are both maintainers of the serverless workflow stream of the CNCF. And across the discussion, he spoke to me about AsyncAPI, which I never heard of it. And well, being a huge fan of OpenAPI, it was directly, I fell in love right straight away. And from there, I started developing the .NET SDK, a .NET SDK for the AsyncAPI, as well as a client and a generator. And that's it, I think.
I hear a cat.
Yeah.
Yeah, he has the talent of inviting himself at the worst times. He's extremely needy creature. Let me in peace from now on.
All right, should I go next?
Yeah, please.
Sure. Hi, so my name is Tihomir. I'm a developer advocate at Temporal Technologies. I've been around like serverless workflow specification for, I don't know, it's been a while, two years probably around now. And yeah, kind of with Charles and a couple of other guys kind of maintain different parts of the project. So yeah, as far as AsyncAPI, we kind of used it before we actually kind of introduced ourselves to your team because we were just fans of it, and we found some really good use cases around applying AsyncAPI specification to what we're doing as far as workflow executions go. So yeah, I think it's a pretty good match, and hopefully we'll see that in the presentation today.
Looking forward. So for those who are wondering, the presentation is called Message-Driven Microservices Orchestration with Serverless Workflow and AsyncAPI. So see you after the talk. Bye.
Hello, everybody. My name is Tihomir. We have Charles here with us, and today we're going to talk about message-driven microservice orchestration with serverless workflow and AsyncAPI. So the table of contents is we're going to introduce the serverless workflow project. We'll talk about a little bit about the project stats and a roadmap, and then we're going to dive into the integration with AsyncAPI and also show a demo that kind of puts it all together. So serverless workflow is an open source, vendor neutral, community driven workflow ecosystem. And if you would interested to get started and learn about it, here's some URLs and links. Most important, just serverlessworkflow.io. You can go there and get all this information there as well. At its core, serverless workflow is a specification-based DSL, or domain-specific language. The DSL itself can be represented as markup, so both in JSON and YAML. And the idea is that as a specification, we define all the rules of the DSL as a JSON schema, so it can be validated and things like that. We also write tons of documentation about every single piece of functionality of the domain-specific language, and we also provide a lot of different examples. We also want to learn and compare ourselves to other technologies and other DSLs out there. So we have a bunch of different comparison documents. If you're interested, if you're coming from a different DSL or things like that, how it compares to serverless workflow. In the end, we are a CNCF project, currently sandbox, working for incubation status. And we have our communities based of people there, kind of knowledge experts in the workflow and the DSL areas as well. So every DSL out there has to conform to some sort of technology or fit in some sort of technology domain. And for serverless workflow, we are in the serverless tech domain, meaning that we really focus on things like defining events and also function invocation. So for events, we use the CloudEvents specification, and what you can do in the DSL is define things like how you want to consume events, how you want to do event correlation, produce events. We have some sort of event grouping if you want to specify some sort of unions or intersections of events that you want to consume or produce, and also provide reusability between different workflow definitions as well. As far as the functions event side or invocation of third-party services, basically, we use standards. So we use things like AsyncAPI, OpenAPI, GraphQL, and things like that, and really kind of focus on using the standards rather than providing some sort of proprietary ways of invoking services and functions, which is kind of typically the case in most of the DSLs that you walk around there. So as far as function invocation, with the serverless workflow DSL, you can define things like invoking, of course, third-party function sync or async, defining retries in case of some sort of failures. You have a way to use domain-specific language within the DSL, so you can name your functions the way that makes most sense to your applications. You can define things like timeouts. You can define error handling again, and again, retries. The DSL itself provides very powerful control flow logic. So it has some sort of core features, which are kind of, people are used to having those, or pretty much must-have type of control flow logic that's present in any sort of DSL or useful DSL, such as, defining a sequence of executions. So you can define your pipelines and stuff like that. Decision-making, which can be either data-based or event-based, things like that. You can define looping structures, retries, human decisions as well. With a DSL, you can define parallel and sequential executions. And of course, it has very powerful error handling features as well. On top of that, serverless workflow also provides a number of enhanced features. So for example, automatic retries, you can define that, your function invocation in case of errors, you want to automatically retry given some sort of retry configurations that you provide through the DSL. You can hook in your secrets and constants and start using those, for example, as values of some parameters that you want to pass to function invocations. We have a very pluggable expression language. Every DSL out there that has to have some sort of expression language in order to make it fully executable. And we allow that to be pluggable. So by default, we use, JQ, but you can really plug in, as you will see in the demo, we're going to plug in JSON path, for example, and use that as well. The DSL itself supports defining both short and long running workflows. And we have other features, for example, continue as feature, which allows you to continue your workflow execution at some point as a new execution or a new completely different type of workflow that needs to continue at some point in time. Compensation, We provide custom function types. So if, for example, even if you don't want to use some of the standards as we defined and have some sort of custom invocation of some sort of services, you can define that as well. Things like cron execution, sleeps, resource authentication, and a lot more. So, check out the documentation and you can really see, and then our examples showcase all of these features as well. On top of the DSL, we also provide some custom extensions. So these are some sort of extensions that you can enhance and use to enhance the workflow definitions. So two that we provide out of the box are key performance indicators extension. So you can use it to define and measure your improvements of workflow as far as performance and cost and all kinds of different things like that. Another extension that we provide is rate limiting. So you can actually define on top of the workflow definition, which invokes some services, whether that be synchronous or asynchronous or whichever way you define them, you can define rate limiting, for example, function invocation, concurrent function invocations per some sort of time and things like that. As far as the user of our project goes or the DSL, you can define your custom extensions as well. So this is not just limited to what we provide. It's very, very pluggable. So we talked about that serverless workflow is an ecosystem. So we don't only provide our specification, but our project on top of that provides some usable things for the community and our ecosystem. So we provide a set of SDKs. We currently have it in Go, Java, .NET, and TypeScript. And these SDKs can help you, whether you're just like a developer or you're building a runtime for our DSL, provides things like parsing, validation, both schema and object type of validation that can be also extended to fit your needs. We provide a set of utility methods, especially if you're developing runtimes. There's a large set of utility methods that will really help you to deal with not having to deal with writing custom parsing logic or some sort of things like that. And we also provide diagram generation. So even though our DSL is not flowchart based or graphical, so it is defined again with JSON or YAML markups, we do provide visualization of your workflow definitions that you define in our DSL. In addition to that, we also host some runtimes in our projects. So we are open to hosting, if you have a runtime that implements the serverless workflow specification and would like to make it part of our project, you can contribute that. And we currently have Synapse, and Charles has contributed that to our specification, which is a Kubernetes native runtime. Now, of course, we support all the different runtimes equally, whether that be, you host it yourself somewhere in your companies or want to contribute it to a project. So that's equal, but there is, just an opportunity if you're willing to. We're more than happy to work with you on hosting and helping you with growing your runtime within our project as well. So in addition to that, we also provide a web tooling support. Basically, we will look at this in the demo. So today, we do provide ways for you to develop and also visualize your workflow definitions using web-based tooling. And also we provide some IDE support, for example, VS Code and IntelliJ and things like that, where you also have some sort of plugins or extensions that help you get started and work with the serverless workflow specification. The most important thing, though, about our project is, of course, the community. Like I said, we are part of CNCF and also the Linux Foundation. We have been a project for, Sandbox for about a year, and this project has been around for longer than that. And the most important thing is our community. We all of us are individual contributors, and we're not backed by anybody right now. So everything that we do, all the help and community support and the whole ecosystem support that we provide is completely community driven and vendor neutral. as well. So as far as adoption goes, this is kind of important, to know for every project. We do have some partner projects within CNCF that we're collaborating with, CloudEvents, AsyncAPI, of course, and things like Tremor and Argo as well. And we also have some open source collaborations with different companies that are interested in using our specification. The list is much bigger than that, but this is what currently we can show right now. So as far as different implementations goes, here are some, of course, implementations that have publicly exposed or allowed us to show, but there is many more that are currently in the works. So hopefully by next year, we will see this list grow a lot more. So as far as any sort of open source project that you encounter, you might want to know some sort of stats about it before you pick it up. So this is kind of like just a short list of things that we have done over the last year, and we have shown as a project continuous growth. We had a ton of different PRs. We had over 2,000 commits by over 30 different contributors from 10 plus different companies. So we are very diverse, and again, we are kind of involved in trying to help everybody that is interested in using the specification. We added 2 new project maintainers, and currently we have 5, all from different companies. So we really show diversity within the project as far as that goes. We added over the last year 2 new SDKs, so we added .NET and TypeScript. And we also released a lot, had a lot of different releases for our other SDKs. And of course, as mentioned, Charles here has contributed the Synapse, which is the Kubernetes native runtime that is hosted in our GitHub repositories as well. As far as the project roadmap goes, this is kind of like a year in review. We started off with kind of like, our release schedule and released version 05 in November last year. We had steady sort of releases throughout the last year. Currently, the current version of Serverless Workflow specification is V07, and we're planning to release 08 next month. As far as 1.0 goes, we're looking currently at April next year. But even now what we're doing is if you're picking the Serverless Workflow project up right now or thinking about using it would be version 07, the latest. And until 1.0, we will only do backwards compatible updates and features. So if you're thinking about starting to use our DSL, you can rest assured that until 1.0 there will be no breaking changes for you, so you can start using it right away. All right, so now to the cool part. AsyncAPI plays an integral role within Serverless Workflow, and basically, like we said, if you look at DSLs right now, probably most of them are going to have some proprietary ways of you having to define how you want to invoke some sort of function or services out there. Workflows itself are orchestrators, right? So your workflow, you define your control flow logic and deal with things like when you want to invoke services, and then you have to deal with like some sort of data manipulations and things like that. That represent your orchestration effort. So what we do is, instead of defining some proprietary ways on how to invoke these services, we use AsyncAPI. We also have other ones, but AsyncAPI is definitely the one for event-driven microservice communication. So we use our specification basically relies on AsyncAPI definitions. So you can have one or more there that define some sort of services that you want to communicate with. And while we're executing our workflow, we define basically in the DSL, all you have to define, as we'll see, is the path to AsyncAPI definition. And you have to provide the operation ID. And with that, basically, our workflow DSL describes everything, what events have to be produced, and what type of channels and things like that. And all is defined with AsyncAPI rather than it being hard-coded or being proprietary inside the DSL itself. So the idea is that the serverless workflow definition utilizes the async API to not only define how this functions or services have to be invoked, and then async API provides all the information to the runtime that executes the workflow definition on how to do that actually. So as far as that goes, then the runtime has all the ability to know, for example, where to send the particular events. That can be, of course, go through all the different types of message brokers that AsyncAPI supports, but also it supports WebSockets as well. So that really allows it for specification-based communication between your workflows or orchestration of your business logic with any type of service, and it's fully described via AsyncAPI. To look a little bit deeper into this, on the left-hand side, we see, for example, JSON-based workflow definition that is written in the serverless workflow DSL. And here in the little yellow box on top, we have a function definitions. These are, the definition that is reusable between multiple workflows and basically defines some sort of function to some sort of service that we might want to invoke during execution of a workflow. So we see here in our function definition that we have a domain-specific name, which is called invoke banking service. And each function definition has a type. In this case, type is async API. So your runtime, when it wants to invoke this function, knows exactly that we're dealing with async API definitions here. And then we have the third parameter called operation. And so this parameter defines the path or the URI to our open API, async API, definition. And just, and then the second part of the operation parameter value is the operation ID. So on the right-hand side, we see our banking YAML async API definition. So what we see here, we have this channel on customer transaction 03 channel, and it has a published definition and with the same matching operation ID that we specify in our workflow definition. And that's it. The async API definition really defines everything. What type of event has to be sent to what channel has to be sent, what should be its bindings basically, and what is the message and its format that needs to be sent in order to invoke this particular service. On the bottom of the left-hand side in the little green box, we actually see the control flow logic of our workflow definition. And we define a single state, and there's different states. Each state or task or step or whatever you might want to call it defines a piece of control flow logic. And in this case, we have an actual action, and this action references our function definition and can pass in some arguments. So at that point, we say, okay, we want to actually invoke this particular service. And the async API definition defines everything that we need to know or the runtime needs to know in order to actually execute it. All right, so let's go to the cool part about the demo. Again, here's some links. If you're interested in our project, go ahead and hit us up on our website or Slack or Twitter and things like that. All right, so let's go ahead. So what we have done is our project is basically, we have, our banking service. Our banking service is using the async API definition that we've showed earlier. So this is the async API definition of our banking service. It basically has a channel, is a publish operation with our send transaction operation ID. And it also has a subscribe channel that it can send results of the invocations events to this particular endpoint. Both of the bindings that we use are Kafka bindings. We can use MQTT or whatever. And since we're running this locally, we have a server which is a localhost port, and the protocol is Kafka. So we have Kafka running locally in our system. Now, what I've done is I've used the AsyncAPI code generators to actually generate this banking service Spring Boot project, so it's all Java-based in this demo, and I've used the tooling to actually generate the whole project. So just from this simple definition with the AsyncAPI tooling, you can generate the whole service. And what I've done only is in the generated message handler. This is the handler which actually, sorry, I'm making this bigger, receives the event that basically comes from our workflow orchestration. And we have also, after we receive the event, we process it, and then according again to our AsyncAPI definition, we send it to our publish channel, the results as well. So that is the application itself. It's Spring, our service that we want to invoke. The second application that I have is actually a Quarkus application, and this is where our workflow, we define our workflow, and also it's able to execute it as well. In itself uses the our banking AsyncAPI definition, the same one that is also describes the service that we just created. And this is used by the workflow runtime. In this case, this is a Temporal. Temporal is a resilient workflow runtime that we also provide some sort of support for, and is able to interpret the serverless workflow DSL, and is able then to from this definition, be able to send and receive events from in this case our Kafka. So that's it. So let's go ahead and start this applications up and see how this works. So let's go ahead and start our service with it's a Spring Boot application, and let's go ahead and start our Quarkus applications, which is our demo, actually, the one where the hosts our workflow definition and the runtime, and it needs to communicate with our banking service. So once we've started that up, also I wanted to just show you, we have Zookeeper here running and a local Kafka instance running as well. And just to show here on the last tab that we're communicating via the Kafka broker, we have a consumer here on our customer account info 3, which is the channel that is defined in our AsyncAPI definition. So let's go ahead and open localhost 8080. Now this is our UI of our actual the Quarkus application, or the demo application. And here we see some of the serverless workflow project kind of utilities, or the ecosystem. On the left-hand side, we have our little web editor that you can use to, for example, define your workflows. And it has things like validation and also auto-completion as well, which is based on the serverless workflow JSON schema that defines the DSL. So you also have validation. So for example, if we removed one required parameter, we should see here, for example, missing property spec version, for example, and things like that. So if you're exposing this, for example, to your end users or customers to define their own workflows, you have a lot of help there, that helps them to write proper and valid workflows. On the right-hand side, we also have a workflow diagram generation. You can change or update your workflows here and click on the button to generate the diagram for the particular workflow that you're writing. So just real quick to go through the demo and the workflow that we're going to be using today. First of all, we're going to look at the function definitions. We do have, similar to what we shown in the slide, a single function defined, which is invoke banking service. It is AsyncAPI type, and it has operation of banking.yaml, which during execution of our workflow is going to be parsed. And we're going to get the send transaction operation ID, and then figure out how to, or where to send our events to, in order to trigger execution of our banking service. As far as the control flow logic go, we have the states block, And here we have a single state. It is of type for each. So we can pass basically one or more transactions as workflow input to our workflow. And for each one of the transactions performed by this particular customer, we're going to invoke our banking service as defined by the AsyncAPI definition and get the results back also. So let's go ahead and do that. So our workflow definition is not, is one thing, and we can execute it. But at the bottom of the page, as you can see, our workflow can have input. It is JSON, but we can also, of course, visualize that in web as well. So here, what we can do in order to start the workflow, we can give it some input. So let's give it let's say a customer ID of 789, for example, and let's do some transactions. So let's say this user had a deposit of $100, and these are space separated. And for the case of the demo, you can do the UI better. So let's say we did a withdrawal of $50, and then we had, let's say, another deposit of $20. So these are type of the transactions that this user has done, and we want to process these transactions with the banking service. If we run the workflow, actually, we will start the workflow. The workflow is going to look at the AsyncAPI definition. When it comes to the actual execution of our banking service, it is going to send, the event on the appropriate topic of our for Kafka, and is going to communicate with the banking service through that. So let's go ahead and run the workflow. Our workflow results are on the right, and I'm going to expand that. So what we see as far as workflow execution goes, we have workflow results, and you can see them also here in our demo. 1 second. Yeah, so result is JSON, but we can also see them in the UI. We've seen that the customer ID is 789, which we specified. We see the transactions that have been entered here as well. And we see all the different functions that have been invoked. In this case, we invoke our banking service function here 3 times for each one of the inputs or the customer transactions that we have provided. And also, since our banking service produces a result back, so via event, we can see here that for this particular user, the current total or the total in their account right now after these transactions is $70, which is 50 plus 20, I guess in this case, that would be right. So let's take a look at also one more thing. So here we have, since we are running this on Temporal and its runtime, Temporal provides us with a web UI as well. And we can see here that we had one workflow that has been executed. It's Serverless Workflow customer transactions. It has a particular run ID. And we can see here that we have completed, during the demo, this workflow execution. Now, if we can also look at the history here, we can see the input, which is the DSL, and also we see here the results as well. And one thing that you can do here also with Temporal, but also other runtimes, probably as well, you can have a complete history of what has happened during the workflow execution. So we can see here that we have executed a number of what Temporal calls activities, or in our case would be the actual request for function execution and things like that. So you have full control with the runtime, and some sort of visualization and information that you can get using Serverless Workflow and as well. So that's it for the demo. I hope you guys enjoyed. Again, thank you very much on behalf of myself and Charles and the whole Serverless Workflow team. I would like to say thanks for having us here on the AsyncAPI Conf, and I hope you have a great day.
That was an unexpected ending. Amazing. I love the demo, Tihomir. I hope you're there. Oh, you're there. Perfect. Loved it. I mean, I was especially on the last part of the talk. I was like, damn, this can have a lot of use cases that we've been discussing even inside the spec. Like many people have been asking us to consider workflows inside AsyncAPI, like, but basic ones, like I received an event here and I want to reply here. But maybe we don't have to. Maybe we can rely on on the workflow spec, right? So that we don't reinvent the wheel. That is super cool. Loved it. Super cool. So we're gonna wait a few seconds more. You got one question during the talk. I'm gonna show it so people can see it. So serverless workflow is the open source version of AWS Step Functions.
Should I take that, Charles?
Please do. It's a classic one. You're trained for it.
Well, in a way, yes. I think I think AWS Step Function is a DSL that's widely used. I think a lot of people are familiar with it. I think, just to say that, yes, number one, the difference is we're specification based, we're open source, we're part of CNCF. So our DSL, just right off the bat, is there is a difference there. But there is more differences. Number one is feature-wise, our DSL is far more complete, I think, and includes a lot more features than what currently AWS Step Functions does. Things like, for example, just using AsyncAPI and other standards that we have shown, that's a huge difference, where I think in Step Functions in particular, they focus more on invoking services within their portfolio and their cloud offering. We are more on kind of like wider use of any type of service and any services that and also other functionalities, especially around events, which is important for AsyncAPI. What we do is you can define event correlations and consumption and producing event inside of DSL itself, where I think, I'm not 100% sure, maybe Charles knows, I'm not a Step Functions expert, but for there you have to use some other or multiple different services to define what you can do with serverless workflow DSL just with the definition alone.
Awesome. I hope this answered David's question. So I was just, in the meantime, while we wait for some more questions, I was thinking that so Lucas was saying that, and serverless workflow is different as it is done with the community. Exactly.
Yeah. And I just wanted to, you look at this as like, guys like Charles, for example, who's here, he came on board and really provided so much value. Just from the .NET SDK, you see Synapse that he contributed. So that's the kind of like why we want to be open source. And kind of like AsyncAPI, I've been watching your conference over the days, and it's amazing how you can communicate and help the community as well. And that's what we're trying to kind of imitate. We're trying to, be as good as you guys in a way. But it is special having like, Charles and others. They just, out of nothing, they just come on board and become such huge contributors to some project is amazing. It's a really nice feeling, and we, and having more of that, and that's really what drives us forward. We wouldn't be really working on this project as much as we do without people like Charles and others who just out of their free time and things like that get hooked into a project and become huge parts of it. So I think that's awesome. Thank you.
So we got another question from Jesse, like how much interaction is there between AsyncAPI and serverless workflow? And he means at community level interaction. I guess it's not about technical stuff, but between the two communities. Correct me if I'm wrong, Jesse. So yeah, I think
you're a contributor, so you go ahead.
Well, so far the interactions have been kind of limited, and happily so, because we just, I believe, entered in contact with each other. The two work streams, right? On my end, I did, like I said in the opening, contribute with a .NET SDK to AsyncAPI. I'm not sure it is released already in the current SDK, but I have a runtime as well that actually supports MQTT, MQP, Kafka, and Nets so far. That reads any kind of AsyncAPI document and is able to interact with it without the user, any user interaction and no configuration at all. This is totally, AsyncAPI's responsibility, in my opinion. Like the document has to define all the information the implementer needs to actually do the required job. And on the other hand, like Tihomir said, I'm working on Synapse, which is like the Kubernetes native runtime. I want to say official, but it's not. It's just it has been given into the serverless workflow work stream, and that runtime. Obviously, I am extremely concerned with its features, and one obvious one was, support of the AsyncAPI specification, because we already had OpenAPI. AsyncAPI was, an obvious addition. We have REST, we have GraphQL, we have OData, we have. Did I forget one, Tihomir? I don't have the list on the
gRPC.
gRPC, thank you. And we are planning on refactoring like more simple basic REST, like what you would find out in AWS. And as well, we have been discussing for quite some time about streaming as well. But this hasn't been scheduled yet, but it's on the table. I don't know if that answers your question.
I hope so. Yeah, lots of details. So that's really cool. We got one more question from Jesse, and he said, "Are there any changes to AsyncAPI that will make it easier to use within serverless workflow?"
Well, on my end, right, Synapse's side, not that I see actually. There might be like some. Still some aspects that I'm not familiar with, some specifications of the AsyncAPI spec. I'm thinking about, like some security features that we could be using, for example, on WebSockets, which is the most obvious one. How all that could fit into or be usable by the Synapse runtime and how. But overall, I believe it's as straightforward as reading an OpenAPI document, providing you have some PubSub background, which is not much to ask in the end.
Awesome. And since we got no further questions, I'm gonna ask mine. So, in regards to communities, to both communities, how do you think we can collaborate tighter from now on? Like, how can we, both communities collaborate?
Well, maybe I can introduce and let Tihomir, follow up on that. But like we discussed, internally as well in serverless workflow, I believe an obvious match for serverless workflow, like Tihomir explained in his presentation, is obviously AsyncAPI for, event-driven architectures. But I believe the opposite is true too, because what's better than an event-driven architecture to prove the point of an event-driven architecture description such as yours? And so I believe there is a lot we could do together, demos that are joining both our techs and many, obviously feedback is always welcome on all the work we are doing there. And as for the rest, the details I will obviously let Tihomir answer, as he's the big boss there.
Yeah, that's a good idea. One thing that I think we would maybe look into adding is, of course, start to using the AsyncAPI tooling support. As we provide maybe integrations with different runtime implementations, we might want to use AsyncAPI tooling to just generate the services from the definitions without users having to do that. On the other hand, maybe one idea that I had, but where it goes, I don't know, is on the other side to start integrating serverless workflow in the AsyncAPI tooling as well. So as you generate your service, you can also apply serverless workflow definition to define the orchestration part, for example, of all the events and things that you're building as well. So maybe there is something there. We can keep looking into it and talk and see where it goes.
You're actually reading my mind.
You know, we're not just the ones. The whole community should, you know, bring their ideas to the table and let us know what we're missing, you know, in the end.
Yeah, I was actually thinking about this integration with Glee, like you know, the Glee framework that we created. Still not version 1 yet. It's not stable yet, but there it could be cool because there's some kind of mechanism in Glee to respond to messages, right? Like you receive a message and then you respond or trigger multiple messages. Sorry. So this could be somehow, I don't know, defined by serverless workflow.
Or reciprocally, because you know that totally concerns the streaming aspect I was speaking of before, right? So far we can send or consume a single event using the AsyncAPI PubSub. But what about being able to have a stream of those events coming synchronously or asynchronously inside the serverless workflow process and be able to trigger behavior based on that?
Exactly. That is a challenge there for us. So that's the challenge that you're solving on your side. Also, so count on me. I say it publicly here, so you get a record. Count on me for shared presentations in case in other conferences where we demo AsyncAPI and serverless workflow together, and I'm sure many more people in the community of AsyncAPI community will also be happy to join. And let's keep exploring. I think it's a great thing to explore. Thanks, folks. So we're gonna have a quick break, short break actually, and then we'll go with with Greg Meldrum from Solace, which is going to replace John Feminella talk, which has been cancelled. And Greg is going to be demoing the sorry, what was the name? Event Discovery, yeah, which is a project that he submitted to the AsyncAPI hackathon. Thanks a lot, folks, and see you in a bit. Bye bye.
See you. Bye bye.
Yeah. All right, folks, welcome back. Are you ready for the last talk of the year, last talk of the conference? I hope you are. We are actually looking forward already for next year conference. We'll share more details as soon as we finish all these questionnaires that we're always sharing in the chat. So yeah, lots of great insights for next year. And let me introduce, or let me just welcome our next speaker, Greg. Welcome, Greg. Greg
Hi,
Meldrum.
Fran. Thanks for having me. I'm really excited to be here.
Thank you. I'm excited that you actually offered to give this talk. I love that you have a lot of guitars in the background.
Yeah, that's my passion. Yeah.
You probably know from a conversation today on our Slack that I love guitars. I don't play guitars. I don't have time, but but I love them. So yeah, that is super cool.
Yeah.
So Greg, will you mind? I wanted to do it myself, but will you mind explaining why you're here today? You were not supposed to be here right now speaking because there it was John Feminella was going to give a talk, and
so I guess there was a last minute request to the community to do a talk, and I put together something really quickly and submitted it, and here we are.
So I want to add something from what Greg said. I want to tell the full story behind it. Like when we knew that there was going to be a canceled talk at the end, and last time, Greg offered himself to give this talk, but they get a pre-recorded talk already, an internal talk at Solace, but that wasn't suitable for I will say for instances. I don't know exactly the reasons, and you did it I think yesterday to record this presentation. It's really in the last minute.
Yeah, yesterday afternoon I spent about an hour trying to record it, so yeah.
So we're super thankful for that, and thanks a lot for taking this effort and with such short notice, and thanks for for adding your talk in the last minute. So,
it's
yeah,
my pleasure. Completely.
I was our pleasure actually. So yeah, like I was saying in the chat, like I want to summon all the Solace folks to support the Greg. It's going to be just a. I want to see how many Solace folks. How do you call yourself at Solace? Solacians.
Solacians. Yes.
Oh, I guess.
And I am a Canadian, Fran, so it's okay.
Oh, okay. Next time I know who to invite.
Yeah, exactly. No, Jesse's pretty good too. You can invite him.
Actually, I love Jesse. That's why I keep inviting him.
He's a great guy.
So yeah, cool thing is your talk is 8 minutes long, so it is really a short and lightning talk. So see you in about 8 minutes, and we'll be here answering questions. Bye.
Bye. Today I'm going to talk to you about the Event Discovery Agent. First, my name is Greg Meldrum. I'm a software architect at Solace. You can reach me at Greg Meldrum at most places. I'm also part of the AsyncAPI Slack if you want to DM me there. So the Event Discovery Agent, recently open sourced by Solace, placed second place in the AsyncAPI hackathon. The tool itself is built to help you understand your event-driven architecture by generating an AsyncAPI representation of the events that are flowing through your system. So the tool itself will connect to your broker and will start listening for events that are flowing through, collect them, reverse engineer a schema if you're sending in a JSON payload, and then create an AsyncAPI representation of those events. The architecture of the agent is layered. So at the top, we've got an embedded React UI. There's also a REST API, which allows you to interact directly with the tool. There's an application layer, which is responsible for controlling the lifecycle of the scan, as well as reverse engineering or inferring schemas out of events that were discovered. And at the bottom layer is the plugin layer. And this is sort of where the magic happens. So in the plugin layer, you write a particular plugin for a specific broker, and this plugin will connect to the broker. It's responsible for collecting messages and then passing them back up to the application layer. So we've got plugins for Apache Kafka, for Confluent. The Confluent plugin actually connects to the schema registry as well and tries to pull out events from there, as well as the Solace PubSub Plus. There are also some other contributed plugins like RabbitMQ, Nats, and HiveMQ. And these plugins in gray aren't really that well tested, but they can at least form the basis for a more fully formed plugin. Now, where can you find it? So it's at Solace Labs in Event Discovery Agent. So the README has a lot of documentation in it. Talks about all the broker plugins, how to download, to build it, to run it, as well as some information on the UI and the REST interface. There's also some plugin developer guides. So let's say you wanted to write your own plugin. So you could go into the plugin developer guide and it sort of walks you through how you would create a plugin for your own broker. Also, there's a UI developer's guide, which Omar Mustafa has put together. And it tells you if you wanted to build a UI for your particular plugin, how you would do that. And now on to the demo. So today I'm joined by a very famous EDA consultant. His name is Martin. His middle name is Fowl because he's a duck, and his last name is Arr because he's a pirate. So his name is Martin Fowlar. And Martin Fowlar is a very esteemed EDA consultant, a big proponent of EDAs, very sought after. So Martin has been hired by this company called Acme Rideshare. And Acme Rideshare has this legacy system on Kafka, and they've sort of lost track with the events that are flowing through their system. So they've hired Martin to help them evolve their system. And the first thing Martin wants to do is actually run a discovery scan on the Kafka broker to get an idea of the messages that are running through it. So we're going to start some traffic here. So, okay, Martin, can you hit enter for me? Thank you. Okay, so now we've got some traffic running. So let's start up the discovery agent. Okay, the discovery agent is starting up now, so it'll take just a few seconds. Okay, so it's running. So now I've gone to the UI here and I've pre-filled a bunch of things. So this is the Kafka plugin UI that we're using. The discovery is Martin's super exciting Acme Rideshare discovery. I put in the host of the broker I'm connecting to, the port that I'm connecting to. It also supports many authentication mechanisms. In this case, I've set up the broker with no authentication just to keep it simple. As well, there's different TLS options. So you can run TLS transport, where you provide your trust store and password, or you can actually do TLS mutual authentication too if you have a key store. Again, in this case, I kept it simple, so I didn't put any TLS there. So you can optionally add in connectors as well. Again, I left that out to keep it simple, and I'm going to scan for all topics. So I'm going to start the scan here. And the discovery agent is now connecting to the broker. It's going to go through all the topics and it's going to pick the last message off of each topic and then try to reverse engineer a schema from it. So we can see here that the agent is reading a bunch of data, and here it's reverse engineering schemas. And okay, so it's done. So we got 12 processed events. So if I go back here to the UI, so I can actually download the results. so here's the scan result. So let's just make that a little bit easier to read. Right, so now I have an AsyncAPI representation. So I could use this for documentation, or what's that, Martin? Oh, good idea. You know what we're going to do? We're going to take this output and we're going to put it in the AsyncAPI playground so you can have just a little better view of what it looks like. So I've got the AsyncAPI playground here. Let's just paste it in here. Right, and now I can see the super exciting scan result. Right, so now I can see, so these are my Acme rideshare events that are occurring. So I can look at the particular payload, I can see all the fields in there. Right, so this provides really good documentation. So let's say I wanted to do some analytics and I just wanted to grab all the messages in a consumer. What I could do is use the AsyncAPI as a starting point and generate some code for event listeners, right? And then that code would take in all the input messages and then be able to do whatever business logic you wanted on those. So that's the demo. Thank you for watching.
That was, I mean, look at Martin. Martin Fall.
Martin Fowl.
R.
I hope I don't get sued.
I love it. I don't think so. I mean, this is amazing. I love it. We should adopt it as the mascot of the project, right? Does the project has a logo?
Yeah, I think it does. I think we've got a telescope or something like that as the logo. But yeah, we could use a duck.
That will be changed, yeah. Telescope is not, that's boring.
Yeah. No, I bought a bunch of rubber ducks for the group. I don't know if you've ever heard of rubber duck debugging, but like when you're debugging, sometimes it's good to have a buddy to explain your code to. And sometimes you actually find the problem yourself while you're explaining it. So that's the whole philosophy behind it. So I bought a bunch for our group at Solace just because it's pandemic and everyone's at home and you don't necessarily have a coding buddy, right? So I figured I'd buy everyone a coding buddy.
That's sweet. Lovely. Yeah. I love this. Yeah, that is actually lovely because, yeah, that has this point of you're not feeling alone anymore. You have a colleague with you there, right?
Exactly.
Yeah, that's a lovely point. Yeah, in this pandemic times, it is really cool. So I guess we have lots of comments, but I don't think we have any questions. Yeah, as Tamimi is saying in the chat, if someone is interested in knowing more, I mean, reach out to Greg, to Tamimi, or to anyone at Solace actually. And yeah, just want to remark something. This project was the third place of the hackathon, but not really the third place. Was also the second place. so we have two second places, right? Like we have, how do you call this? You had you have the same amount of points.
Tie.
A tie, yeah, exactly. Yeah. I couldn't find the word. So there was a tie in the second place, and so yeah. So this went to raise that it was super cool and well documented project, and deserved the prize for sure.
Yeah. And in terms of the tooling too, like at Solace, we have customers who are embarking on their EDA journey from a greenfield perspective, and we have others who already have an existing system. So we saw a need for a tool to really help them understand what they had in production already. We started building this, and then we thought, okay, this is too good to keep to ourselves. This is something the community could really use. So then we open sourced it a couple of weeks ago and entered it in the hackathon.
That is super cool. Love it. So yeah, it's true. Like we always think about greenfield projects, but I mean, there are, especially big companies have been doing EDA already for a long time. So yeah, they're not starting from scratch at all.
Exactly.
Cool, Greg. So thanks a lot for this last minute submission and recording, and for entertaining us with the rubber tag.
I'm glad you enjoyed it.
So thanks a lot, and let's keep chatting. Let's see you around on the Slack channel, and the community.
Sounds good. Thanks, Fran.
Thanks. Bye-bye.
Bye.
All right. So I'm not gonna do any break yet. I'm gonna invite my folk, Lucas Gorniski, to stage. I'm gonna keep you there. Yeah, just there is much better.
You forgot that I have the same power.
I forgot that you have control. Damn it. Downgrade permission now. Where is it?
Blocked.
So maybe block it. Maybe you want to say something, Lucas, or you want me to start inviting other people?
No, I like to say huge thank you for it's the end, but I think it's the most important now to invite few folks. So even though during the event you could mainly see like these two faces, shit, I always have problems with pointing the right direction. But even though there are two faces visible now, there were many other faces supporting the event. So I told you that, like, in general, we had over 60 people involved in organizing the conference, putting us in contact with sponsors, helping out with website, like a bunch of different areas. But also important, like that during the conference, like the when it started, getting all these comments, like sharing information online. There was a group of angels, supporting us. So I'd like to first of all mention names, because not all of them could join us now. So it was like super a lot of effort from Kuda, from Maciej, from Missy, from Visva Prasad, and Alejandra, and not all of these amazing people could join us, and Sergio. And not all of those amazing people could join us, because you know how we started. We started like a few hours ago. Some people, it's already 1-2 a.m. in the evening, but some of folks could join. So now, Fran, you can start letting in these amazing people.
Yay!
Hi.
Hello. I think we can hide sponsors now. They were pretty much exposed pretty well, I think, during the whole conference.
Okay.
I didn't hear anyone inviting Canela.
Oh. Oh, no, not this one.
So yeah, thanks a lot, Missy, Alejandra, and Maciej, and whoever's behind him. Thanks a lot for joining. And I would like to ask everyone who's still with us at the conference to have a virtual round of applause, because it's really, it would not be possible to run it alone or in two persons just. So thank you.
Yeah, thanks a lot. Really.
Yeah.
And we should be now playing music or something like that, grabbing some beers, right, and celebrate, right? Yeah. But that's maybe next year.
I think that's the biggest issue of online events. Like normally we would be on stage and have a round of applause, and then right after we would went for a few beers, probably.
Well, Greg says that he's producing a AsyncAPI song, so maybe we'll have that for next year.
Yes, on the stage.
Wow, that's a good idea. Maybe next year we should have less Lucas, though, because I'm not sure how like extended amounts of exposure to his face could affect the overall community.
Yeah, the SEO, definitely, like the positioning of videos will drop. So
oh, we'll get reports of like more seizures. I saw his face and started seizing. Okay, I'll stop. Sorry.
I can't handle it sober, so. So yeah, anything anyone wants to add before we finish?
Jonas is actually saying happy birthday to AsyncAPI. So yeah, let's not forget about this. Let's not forget that it's AsyncAPI for 5th birthday. So yeah, thank you all. Like, this is a great community and it's amazing. I did git push and look at this. How the hell this happened? Well, this is a great summary of things, I would say.
With so many different meanings. So yeah, 25 people responded to our questionnaire about like a few questions about AsyncAPI, and I think the most important is that 72% of people said that we need hybrid approach, so in person and online. So if you want to help make it happen, we should probably kick off next week, work on next year's event, maybe in 2 weeks.
Already.
Yeah, I was about to say that, like give a week of rest maybe, and then we can start.
Some recovery time for the soul.
Yeah, but yeah, in person will require even more and more work, but also I count on especially vendors, because in person we should make also it possible for vendors to showcase their solutions, so it might be much bigger. And but yeah, let's stop talking about it. We just finished and I want to start thinking about the new event. So yeah, thank you.
Thanks a lot, Lucas. And thanks a lot, everyone, for organizing this amazing conference. And thank you all for attending. See you next year. Bye-bye.
Bye.